Hello team, welcome back. And we are starting a new training on Docker and Kubernetes. This training is going to helpful for those people who don't have the knowledge of the Docker and Kubernetes or who have the knowledge of any one of these technologies, but they also want to get the knowledge of both. In this course, we have designed the curriculum in a way first you will get the basic understanding of the tools and then you will move to the advanced level. So let's move forward and see what we are going to cover in this course and what are the things you are going to learn. So this course is aimed for the individual who are looking for the Docker and Kubernetes masterclass course. So this is going to be very detailed course on the Docker and Kubernetes concept with a hands-on lab on the Docker and Kubernetes. The course is going to helpful for the DevOps people, DevOps automation engineers or software engineers who are basically working on the application so that application natively support the Kubernetes model. So I am Anshul Chauhan and I am going to be the instructor throughout this course. If you will get a view on the instructor's profile, then I have total 21 plus courses available on the Udemy, and as of now, total 230,000 people are learning from our courses. The instructor rating is also good. We have 18,000 plus reviews on this profile, and overall rating is 4.6 plus, which is definitely a good one. So this course is going to be a perfect place for the people who want to go with the Docker and Kubernetes specialization or who want to start with the Docker and Kubernetes. To start with this course, you don't need any prior knowledge of the Docker or Kubernetes. We will start from very scratch and we will show you the path of the advanced levels. There is another important aspect that what is the things we are going to learn as a part of this course. So let me explain. Very first, we'll start with the Docker part because to understand the Kubernetes, which is a complex thing, first you must have the knowledge of the Docker. So we will start with the Docker. We will see the Docker requirement, Docker installation. We will go with the Docker basics, where we will create the container at a runtime. We'll execute the container with a different way. Then we will go with the Docker images, which is a deployable images in the Docker, where we will see how you can create the image of your software application, how you will execute your application within the Docker environment. Then we will go through the Docker networking, where we will understand the different networking aspect, that how you can access your application, how the external parties can access your application, how you can expose your application on the host machine, and how you can expose your application on the DNS. Then we will go with the Docker volumes, where we will learn about the stateless and stateful containers. We will learn that how you can manage the stateful application, the application like the database or any application who is basically executing on the persistent data, how you can manage these applications using the Docker. Then we will go with the multi-container, and first we will go with the multi-container on the local setup. It means developer machine. So we will use the Docker Compose. Then we will go with the Docker orchestration, that how you can execute the multiple container in the Docker, and as a combine, you will produce a single application to the end user. For the Docker orchestration, we will learn about the Docker Swarm, which is a native orchestration tool available for the Docker. And then we will see that what are the differences between the Swarm and K8s, which means Swarm and Kubernetes. So this is the part, these are the things which we are going to cover as a part of the Docker. And over here we are just getting the headlines of the sections what we are going to cover, but while you will start learning, you will see that we will cover these things in very deep, right? So we will get the in-depth knowledge of the Docker, Docker Swarm, Docker Compose, Docker orchestration, multi-container applications, and the stateful and stateless application in the Docker. Once we will go through all these things, we will go with the advanced part, the Kubernetes, which is a bit complex compared to the Docker, because Kubernetes is an orchestration application for the Docker, right? So if you want to learn the Kubernetes, you must have the prior knowledge of the Docker. So that we have included all the Docker part in a first and moved the Kubernetes into the second half. In the Kubernetes, we will see that what is the requirement of the Kubernetes, what are the purpose Kubernetes is fulfilling in the market, how we can install the Kubernetes. There are multiple ways. So we will learn about the self-managed service, and we will also learn about the cloud managed services in the Kubernetes like GKE, EKS, and Azure Kubernetes. Then we will learn then we will go through with the Kubernetes basic, that what are the terminology of the Kubernetes, how Kubernetes is actually working, what is the infrastructure of the Kubernetes, what is the architecture of the Kubernetes. There are going to be a lot of things which we are going to cover. Then we will see how we can manage the Kubernetes cluster. If you are installing your Kubernetes cluster, that is a single node cluster or multi-node cluster, how you can manage your Kubernetes cluster, how you can become the administrator of your Kubernetes cluster. We will see the Kubernetes advanced part where we will see the multiple things which you can achieve using the Kubernetes, but it is a very hard to achieve in the Docker. Then we will see how you can do the deployments in the Kubernetes. There are multiple ways and we will see all of them. We'll also learn about the Kubernetes networking, which is definitely an important part. We will see the Kubernetes services and storage. Here, Kubernetes services means the Kubernetes object which you will deploy for your application access. We will go through these things in very details. Then we will see the load balancing in the Kubernetes, how Kubernetes perform the load balancing and what types of load balancing available in the Kubernetes, and how you can opt out the correct load balancing for your application. We will go with the self-managed service in the Kubernetes, the Helm package manager in the Kubernetes. Using the Helm, you can bundle and deploy your application in the Kubernetes cluster. So these are the other things or the second part which we are going to cover for the Kubernetes. So this is the complete structure. We have seen that what are the things you will learn in the Docker and what are the things you will learn in the Kubernetes. This training is a complete course, or you can say the masterclass course for the Docker and Kubernetes. And the people who are interested in the Docker and Kubernetes technologies, they can enroll this course. Few of the learner may have the question that at what level I will stand out after this course. So let me tell you that these are the things which you will do after the completion of this course. You will be able to understand, deploy, use and manage the Docker containers. There is no need to search and Google out the things that how we can manage, use, deploy the containers. You will be able to understand, deploy the containers on the production using the Docker Swarm. So the container orchestration, that how we can deploy the containers, how the application will behave with the multiple containers. You will be able to deploy the things in the production using the Docker Swarm. If you are using the Docker Swarm, then you will be able to deploy. You will be able to use the Kubernetes on the production containerized application, that how Kubernetes can be used to orchestrate the containerized application in the production. You will get the complete understanding and you would be able to do so after the completion of this course. You will be able to run the stateless and stateful application on the Kubernetes, because there is a specific nature of the stateless application and the stateful application, and this is a bit complex part while we are executing the application in the environment like the Kubernetes or the Docker. So you would be able to run the stateless and stateful both kind of application on the Kubernetes. You will be able to manage the production application on the Kubernetes, because in the production there could be the multiple things like the security, networking, load balancing. So you will get the complete knowledge of the Kubernetes so that you will be able to completely manage your production application on the Kubernetes. You will be also able to administer your production K8 cluster. So if you are using the managed service where the Kubernetes as a service provided by the different cloud providers, then the administrator part is the cloud provider's job, right? Still you need to do some kind of maintenance, but most of the things will be done by the cloud provider. But if you are using the on-prem installation of the Kubernetes, where you are installing the Kubernetes and you are creating your own cluster for the production deployment, then you will be able to administer the complete production Kubernetes cluster. You will be able to understand what are the terminologies and how we can manage these things as a Kubernetes administrator. In the last, we will cover up the Helm package manager. Using the Helm package manager, you will be able to package your application and execute your application on the Kubernetes using few single commands. So these are the things which you will be able to do after the completion of this course. So as this is going to be online course, you may face some kind of problem in the lecture. If you are getting any problem in any lecture, you can raise your question in the question and answer forum. Each lecture have the associated question and answer forum, so you can put your question over there and we will reply as best as possible. Once you will complete this course, you will get the digital soft copy, the certification copy of this course, and Udemy will issue the certification for this course. So you can put that certification on your LinkedIn and LinkedIn certification section. There is another big and major concern, that what about the course material and the code files? So as a part of this course, we will develop the multiple code files, configuration files, text file, JSON, YAML files. So how you will get these files, right? So you don't need to write any kind of file from scratch. If you want, you can do it, because practice makes the things better, right? But If you want to get some kind of help that what are the file we are using, whatever the code we are using, so we will basically check out the complete code in the public GitHub repository, and I will provide you the locations of the GitHub repository. You can easily go to the GitHub repository, download the code, so that you will have all the code, whatever the code files we are going to use as a part of this course. So this is the complete picture of the course. I hope you are able to understand that what we are going to cover. All I can say that this is going to be a perfect course for you if you're learning about the Docker and Kubernetes. Good luck, happy learning. See you in the coming lecture. Hello team and welcome back. Today we will discuss what is Docker and why Docker. What are those things which is making the Docker so much popular, and why companies are adopting the Docker over the traditional VM based solutions. So in a nutshell, if I will mention, then Docker is the future of software management. You will see that Docker has done the revolutionary changes in the software development or software management, because there are multiple things using which Docker has minimized the operational cost and maximized the application availability. So what are those things? Docker is a hotter than hot because it makes it possible to get more and more app running on the same old server. And additionally, it also make it very easy to package and ship the program. So that is the complete life cycle of the software application. You build the package, you ship the package, and you execute the package. And along with the easiness, it is more pocket friendly, that if you was executing a single application on a single VM, after the Docker, you may execute the 20 or 30 instance of the same application on the same VM. Shortly we will see that what we are talking about, but right now you can assume that using the Docker, you can execute more and more app on the same VM, where earlier the only single app was running on that VM. And Docker make the software build, package, ship, and execution very easy. Docker came in 2014, and after that a lot of products come from the Docker. But there are three innovations which makes the Docker the futuristic tool, and these are the Docker image, Docker container registry, and Docker container. Docker image is a bundle package of the executable code. Docker Container Registry is a registry where you can ship that particular executable code, and Docker Container is that executable code which is actually executing. So these are the three innovations which Docker done. Image, which is a package or build or bundle of the code. Docker Container Registry, where you can put the bundle or your execution code. There are multiple container registry available, but the common container registry is the Docker Hub. And then the container itself, which is a executable instance of that code. I mean to say the executable instance of the Docker image. So what is the Docker development backbone? If you will go to the traditional software development, then you will see that what is the software development? Software development is build, ship, and run. In the build, you are building your artifacts. In the ship, you are shipping these artifacts to the production or to some other VM machines. And in the run, you are basically executing these artifacts on the VM or on the production. Same thing is being done with the Docker, but in more easy way. Once we are saying the software build in terms of the Docker, that is a Docker image, which is a executable bundle or bundle of your software code. Once we are saying to ship, where you are shipping your artifact in terms of the Docker, you are shipping your artifact, your Docker image on the Docker registry. And once we are saying that on a VM based solutions, you are executing your application. Here in the container, you are executing your container, and your container is a running instance of your application. Let's understand why companies embrace the Docker containers. And there are multiple reasons why companies are embracing the Docker containers. What I would like to mention a very few, and you will understand that why the companies are embracing the Docker containers. The very first is use of shared operating system. Earlier, before the Docker, what is the model of the application execution? You need to create a virtual machine, or you need to create a machine, and on that machine you will execute the single instance of your application. But with the Docker, this is not the case. You can execute n number of Docker container on a same machine on same operating system, and each container will be a separate instance of your application. Earlier, where only one instance was executing on one machine, after the Docker, you can execute the n number of instances of the same application on the same machine, which is providing two features. First, it is very cost effective. Second, you are getting the high availability application in minimal cost. Second is continuous integration, delivery, and deployment. The same thing, build, ship, and run. Developers are basically developing their code. They are creating the artifact in terms of the Docker image. They are delivering these artifact to the Docker registry, and they are doing the deployment. They are creating the containers, right? So the Docker containers are making the CI/CD, the DevOps part is very easy, because over here you are basically doing the integrations continuously, you are delivering that images continuously, and then you are doing the deployment on the same way. So in nutshell, the Docker enables developer to easily pick, ship, and run any application as a lightweight, portable, self-sufficient container, which is a executable instance of a application. And last is easy to deploy in cloud. All public cloud providers are natively providing the support of Docker and Docker orchestration, right? Even almost all public cloud providers have their native container registry as well. So these are few things which are making the Docker the futuristic tool, and I hope you got the point that why Docker is so much important and why Docker is the default choice of the IT companies in these days. One more thing, whatever the operations you want to perform on the Docker, either you can perform from the CLI, the command line, or Docker have the software development kit available in the different programming languages like Python, Java, you can use them. So thank you team. See you next time. Hello team, welcome back. And today we will discuss why Docker and why Docker matters for the developers. So there are the multiple reasons that why we are using Docker, and we are going to discuss few of those. So very first, let me try to explain why Docker matters for the developers. So this is a very famous statement, and I believe either you have heard it in your career or you have already said it to someone else in your career, but it was running on my machine. So generally the software developers use this line while the application breaks on someone else's machine, either their friend's machine or the software tester machine. And I believe every developer has said this in his life while shipping the app to friends or the tester's machine. So does it mean the developer is developing the application to execute on their machine? No. Developer is developing the application so that he can build it, ship it, and execute it on the production environment. So what are those reasons why the application is mostly work on the developer's machine and it fails on the tester machine, or it fails on the production, or it fails on the someone else machine? So Docker is the answer, and Docker helps developer to solve these problems and provide a system independent runtime environment for the application. Yes, that is a very true statement. Docker provides a system or OS independent runtime environment for the execution of the applications. And that is the thing which makes the Docker so much popular. So we are going to discuss a few reasons that why the IT industries are adopting the Docker and why Docker becomes so much popular in very short time. So the first reason the Docker becomes so much popular is environment isolation. So as a developer, it was a really tough task to configure the application for the different version of a software on a single machine. Now you can create the isolated environment called the Docker container with the help of the Docker, and each container may have the different version of your application. Like in this diagram, we can see we have a single host machine. This is a one operating system. On this operating system, basically we are executing the Docker runtime environment. This is the Docker runtime environment, and on this Docker runtime environment we can execute n number of container. You can see we are executing almost 6 container on a same machine, and each container either a different version of the application, either they could be the same version of the same application, or either they could be the different application. This was not happening before. On a single machine, you can only and only execute a single application. But with the help of the Docker, you can execute multiple applications, or multiple version of a same application, or multiple instances of the same application and same version. And the conclusion is you can execute the multiple instances or multiple application on the single operating system or single machine. This was not happening before. Either you can achieve short of it using the virtual machines, but that has a different drawbacks, because in the virtual machines you need to reserve the number of CPUs, you need to reserve the computer resources. With the Docker, you don't need to reserve the resources. Shortly in the coming lectures, we will also see that why we don't need to reserve the resources with the Docker, because once you will execute the Docker container on your machine, it will demand the resources at runtime. In the coming lectures, we will also discuss that if you want to launch a Docker with the static resource with some kind of CPU and some kind of RAM, how we can do it. But the basic nature of the Docker is not reserve the resources on the system. It will demand the resources from the system at runtime on basis of the application use. So the first and biggest reason is environment isolation. Docker provide the isolated environment for each application, or you can say for each instance, or you can say for each container, because Docker create the instance of your application, or you can say the runtime instance of your application in a container, which is a separate and isolated unit. The second reason is OS independent application. Yes, that is true. Using Docker, you can make your app platform independent, and running a Docker container on Linux, macOS, Windows, or any operating system, because Docker is not executing on the host machine operating system. No, while you will execute the container, that container will have its own operating system. We will see, and I will show you that how you can use the different operating system in a different Docker containers, and you can execute all these containers on a single machine. And it doesn't matter that the host machine on which you are executing the multiple Docker containers, that machine is a Linux machine, Windows machine, or a Mac operating system machine. So in this diagram, you can see this is a one container, this is a second container, and this is a third container. And these containers are basically not interacting with the operating system. No, they are interacting with the Docker runtime environment kernel. And that Docker runtime environment kernel is basically interacting with the operating system. So these containers may have the different operating system. You can see over here we have a three containers, and all three containers are using the different operating system: Debian base, Ubuntu base, and Alpine. So first thing, the Docker application is the OS independent, and you can execute the multiple operating system, the different operating system on a same host machine in the Docker. With the help of the Docker, you can achieve the rapid deployment and the development. Docker efficiently organizes the entire development lifecycle by providing the standard working environment to the developers. So developer need to know that how they can create the Docker container, the individual Docker container for an independent process. And the one more advantage is that Docker app do not boot with the operating system. If your operating system is booting, then the Docker app will not boot with your operating system. So it will also save a lot of time. So the Docker containers come up with a minimal runtime requirement of the application that allow them for the deploy faster, right? So Docker provides the rapid development and the deployment. Another reason is scalability and flexibility, which made the Docker more easy. So let's suppose you are not using the Docker and you are executing your application on a standalone machine. So here are few machines which are executing your application instances. Over here, these are three machines which are executing the three instances of your application. And you can see now in a days, the application is getting the traffic on event basis. So let me take an example. Suppose you are working for some e-commerce product, and that product are getting the traffic on a basis of the deals. It may get the traffic on the basis of the sales. It may get the traffic on a basis of event like a cricket match, a football match, or it may get the traffic on a new movie release. So there could be the n number of possibilities where the application may get the traffic rapidly. In that case, if you are not using the Docker, what you need to do? If these three machines are not able to take care of your environment, what you need to do? You need to spin up the new machines. And spin up the new machine from scratch is definitely a big task. This is not an easy task. So let's suppose you are using the Docker. What Docker can do? There could be the n number of machine. Let's take an example. There are two machines. And in these two machines, there could be the n number of Dockers. Right. So let's suppose initially these Dockers are executing, or these containers are executing on your
host machine. Suddenly you got the traffic. So you can configure the Docker in a way that whenever we are getting a more traffic, Docker will be able to launch more containers. So once the traffic will increase, Docker itself will increase the number of containers and it will try to serve the traffic, right? Docker will itself increase the number of containers. You don't need to increase the number of container at a runtime. And because Docker is executing the lightweight process and the runtime is very minimum, so you can scale your application very rapidly. So this is the another feature which comes up with the Docker and which is a very useful feature. Next is no more security issues. With the Docker, you have the less security issues. Why? Because Docker container are more secure than the ordinary app. Even in the container, you cannot access the data from the other containers without having the authorized access. That is not possible that the container can interact with each other, they can access the data of each other, or they can access the state of each other if they don't have the authorized access. Also, you can add the multiple security layers if you want in the Docker to ensure the security. So Docker is more secure as compared to the ordinary applications. The next reason is the ship anytime and anywhere. The application migration or the shipment has always been considered as a very long task, which is not only requires the human resources but also consumes a lot of time in configuration and setup. But Docker is a game changer here. It allows you to freely ship your application anywhere, anytime without your worries. And all you need to do, you just need to publish your image on the registry and you have the Docker runtime environment at the support system or the machine where you are exposing or the machine where you are expecting to execute your Docker containers. So what you need to do, you just need to install the Docker runtime environment and the artifact of your Docker, the artifact of your product should be available on the registry. Docker will automatically fetch that artifact and execute your application instance on the machine where the Docker is installed. That is way easy compared to the earlier shipment where you need to ship your application on the other machines. You need to create the machine, you need to configure the application, you need to configure the hardware, and then application will come up. The another reason is dependency management made easy. Because in the Docker, while you are creating the Docker image, which is a application code, then with the application code, you also need to mention all the dependencies which your application need to execute. So that is a bundle and ship kind of thing. Bundle all the things in a single packet and ship that. And once the Docker will execute it, all the dependencies should be already configured in the image. You don't need to download the dependencies at runtime, right? So it make the dependency more easier. And the another one is inbuilt version control system. Docker images also follow the versioning, right? Whenever you are going to push the new images and incremental images of a same product, Docker will itself version the images. You don't need to explicitly do the versioning. If you want, you can do, but Docker will itself version the images. So you can see these are the major factors, or you can say the major reasons which are making the Docker more convenient for the developers and the IT companies to execute their application for the production. So these are the few reasons why you should go with the Docker. From the coming lectures, we will start learning about the Docker in depth and we will go with the installation and all. Thank you, team. See you next time. Hello, team. Welcome back. And now we have a little knowledge of the Docker, that what is Docker and what is the related context of the Docker. We will move further and we will see the installation. So this particular section is all about the installation because Docker provides the multiple type of installation. So we will see that what is the right installation for you and how you can do the Docker installation. So very first, whenever you are going to start the Docker, the first question is which Docker you will be using. There are multiple flavors available with the Docker and we need to decide that which is the suitable Docker for us. So majorly there are two things which you need to consider while you are installing the Docker, and the first is Docker Desktop. A Docker Desktop is a complete end-to-end application for the Docker environment on desktop machine for the developers. So as I mentioned the desktop machine, I mean to say that the Docker Desktop is only suitable for the local installation. I mean to say the desktop installation. If you want to provide the Docker installation on the server, then there is another kind of installation which is a Docker engine. Docker engine is a Docker addition for the server side installation, which will be preferred for the servers and the cloud machines. It is only compatible with the Linux. So for the local installation you need to install the Docker desktop, and for the servers, for the server machine or the cloud machine, you need to go with the Docker engine. As I mentioned, the Docker engine is only compatible with the Linux machine, but you will get the multiple flavors of the Docker desktop. You can install the Docker desktop on the Ubuntu desktop, on Windows, and on Mac operating system as well. Docker desktop provides a very simple interface that enable user to manage the containers, application, and images directly from the local machine. So because Docker is a very famous tool, so you need something which can support the developers to develop the application over the Docker, which is a complete end-to-end environment for the Docker application to develop the Docker on your local machine. But whenever you want to execute the Docker on the server side, you need to use the Docker engine. Let's see what is the Docker environment includes in itself, or what is the Docker desktop includes in itself. So Docker desktop include the Docker engine. So basically the Docker engine is the core engine which will execute the Docker, or you may call it Docker runtime environment. Apart from the Docker engine, the Docker desktop have the Docker CLI client. Docker CLI client is a command line interface which you can use to interact with the Docker. Then we have the Docker buildx. Docker buildx is used to build the Docker images. Then we have the Docker compose, which is a development oriented tool for the multi-container setup. Then we have the Docker content trust. Docker content trust is used to basically authorize the data which Docker is requesting, or you are requesting for the Docker. So it will manage the Docker certificates and the keys. Then we have the Kubernetes. If you are not aware with the Kubernetes, then Kubernetes is a Docker orchestration system where you can orchestrate your application which is using the Docker. Then we have the credential helper, which will help us to store the credential or build the credential locally. So these all are the component of the Docker desktop. That's why I mentioned that Docker desktop is an end-to-end solution for the Docker application development. Now let's go through some key features of the Docker desktop. So Docker desktop have the many features. So using the Docker desktop, you are getting the ability to containerize any application and share it over the cloud. You are getting a very easy installation and setup of the complete Docker development environment. Apart from this, you are getting the Kubernetes integrated environment with the Docker to execute your Docker on the Kubernetes environment. And if you are using the Windows, then you can toggle between the Linux and Windows environment to develop your application. And Docker desktop is using the Windows WSL2, which is a native Linux compatibility on the Windows developed by the Microsoft, right? So you are getting the ability to work natively on the Linux through the WSL2 on the Windows machine. Volume mounting for the code of data, including the file changes notification and the container volume or the local host network. These all are the features which comes with the Docker desktop. So Docker desktop is a complete end-to-end Docker development kit. So using the Docker desktop, you can develop the containerized application end to end on your machine. In the coming lecture, we will see the installation of the Docker desktop and what kind of installation is available for the Docker desktop. So thank you team. See you in the coming lecture. Hello team, welcome back. Now we have the idea what is Docker desktop and what is Docker engine. So very first we will see that what is the installation process of the Docker desktop. And in this lecture, we will also see how we can install the Docker desktop for the Mac machine. And to go through the installation of the Docker desktop, we need to open the browser and open the Docker official site. So here we are on the browser and I will type for the Docker. You will get the official site of the Docker, www.docker.com. Let's go to this site. And very first on the top of the site, we are getting develop faster, run anywhere, download Docker desktop. And the Docker desktop is available for the Apple, Windows, and Linux. Let's go to the pricing. And if you will go to the pricing, then you can see there are few plans: personal, pro, team, and business. Personal plan is ideal for the individual developers, education, open source communities, and small business. So to start using the Docker desktop, you don't need to pay any money. This is officially free of cost for the developers and education. As we are learning the Docker, so we can use the personal plan. If you will click on the start now, you will see you are getting a page of create Docker account. We will come to this later. Very first, we will see the installation of the Docker desktop. So let's go to the home page, and here you can see the download Docker desktop is available for the Mac operating system Intel chip, Mac operating system Apple chip, Windows and Linux. So once you will click this link, if you will click over here, it will start to download the DMG file. This will also start to download the DMG file. This will start to download the exe file, and this will start to download the zip file. Go to the new tab and type Docker desktop. You will get the link of the docs.docker.com. Install Docker desktop. Let's open this link. This installation is for the Windows operating system. Over here you can see we have the parent install Docker desktop, and we are getting the installation guide for the install on Mac, install on Windows and install on Linux. So if you are using the Linux operating system, you need to follow these instructions, whatever the instructions are given over here. If you are using the Windows operating system, then you need to follow these instructions, whatever the instructions are given over here. And if you are using the Mac operating system, you need to execute these steps. So for the Mac operating system, there is two kind of installation is available, one for the Intel chip and another one for the Apple silicon chip. So you need to be make sure that what is your Mac operating system chip type. If it is Intel, you need to download this version. If it is Apple silicon, then you need to download this version. Let me verify what is the chip for my machine. I will click this Apple icon, go to the about this Mac, and you can say the processor I'm using is the 1.8 gigahertz 12 tone Intel Core i5. So I will definitely go with the Intel chip. So I will click it. This will download the DMG file. The size is 556 megabyte. Let's wait until the complete download will be done. The file download is done. Now if you will go to the install Docker tab on the Mac, it is saying double click the DMG file to open the installer and drag the Docker icon to the application folder. So I will double click it. It is opening the DMG file. Let's wait until the verification will be done. So once the installation will be done, you will get a window like this. What you need to do, you need to drag this and release it over here within the application. Once you will drag it and release in the application, in your applications you will get the Docker icon, and it is here. You can see the installation isn't done or this transfer is in progress. We have to wait until the progress will be done. You can see the transfer or the installation is done. Now the Docker icon is available within my application. What is the next course of action? Next is double click the Docker app in the applications folder to start the Docker. So what I need to do, I need to double click this icon to start the Docker. So I will double click this icon and wait for the Docker to start up. It may possible it will ask you that Docker is trying to install a new helper tool and it will ask your password. You need to provide your password and click on the install helper. Now you need to accept this agreement and you will get a message Docker desktop is starting. Let's wait until the Docker desktop will be started. Now once it will done, it will ask you to get started with the Docker in few easy steps. Estimated time is 2 minutes. Click on the start. Now it is saying that getting started project is a simple with GitHub, so we need to clone the repository. I will simply click this icon to do this. You can see it is downloading some image and it will start a temporary container on my machine. See, this is done. Now go to the next step. It is saying that go to this getting started, the repository which is being downloaded from the Git, and execute this command. I will click this arrow. So what it will do, it will go to the Docker started and basically creating a image, right? Don't worry, I will explain each and everything, whatever the thing we are doing over here or whatever the things are happening in the background. I will explain each and everything shortly. Right now, just go with the installation, whatever the installation Docker is saying to execute. So if you want to relate, I can show you that right now it is basically creating the image, right? It is basically creating the image of your source code. and then it will push that image to the Docker registry. It is done. Go to the next step. Now it is saying run this command docker run -d-p port 8080 name docker tutorial, and this is the name. Let's execute this command, and you can see the container is being started with this particular ID. Click on next. It is saying now save and share your image. It's done, right? So we will go to the dashboard. Over here, if you will go to the images, you can see the new image is being created, Docker 101 tutorial. This is the image which we just created, right? If you will go to the containers, you can see a container is running, name is Docker tutorial. So this is the container we just started. So this is the very simple interface what you will get in the Docker. If you want to delete it, simply click on delete forever. If you want to delete the Alpine as well, click on delete forever. In the image, if you want to delete this image, delete it. Remove the image, delete forever. Remove this image, delete forever. So this is the way how you can work with the Docker desktop. Once you will done this installation, if you will go to your menu, you see you are getting this icon over here. This Docker icon is called Mobi. And over here, if you will click this, you are getting a lot of options over here, right? The extension, Kubernetes, pause, restart, and quite Docker desktop. So there are few things which you can get over here. On the same way, if you will install the Docker on the Windows, you will get the icon. You will get this particular icon in your Windows machine, and you will get the similar kind of UI on the Windows. If you will install the Docker desktop on the Linux, you will get the similar UI. So the Docker desktop UI is going to be the same, irrespective of you are using the Docker desktop on the Windows, Linux, or Mac, right? So the Docker desktop UI experience is going to be the same. That is not going to be the different. The installation process may be different, depend to OS, right? And for the installation, you will get the complete help from the official documentation. For the Windows, you need to download the exe, right? After the exe download, you need to follow this. Whatever the commands mentioned over here, you need to follow these. So team, this is the way how we can install the Docker desktop, right? If you have any doubt, any question, you can ask me. Thank you team. See you next time. Hello team, welcome back. And we have seen that how we can install the Docker desktop on the local machine. But we also need to understand that how we should install the Docker engine, because Docker desktop will work for your local machine, but for the server side installation, you need the Docker engine. And I must believe that every learner who is on this course are not the developers. They are the DevOps engineer as well, right? And if you are a DevOps engineer or you are a developer where you need to support the production as well, then you should know that how to work with the Docker engine on the server side. For the development, it is okay to have the Docker desktop, but for the server side execution, you need the Docker engine. So as a part of this lecture, we will discuss about it, that how we can install the Docker engine, what is the system requirement do you have for the Docker engine. So for the installation of the Docker desktop, you just need your desktop machine. You can install the Docker desktop either for Windows, Linux or Mac, and you can install it using the given instructions. And we have seen that how we can install it on the Mac, and we was good to use it. But if you need to install the Docker engine on the server side, where you are executing your application on the production, that how you should install the Docker engine. What is the system requirement do you need? So very first requirement is the Docker engine installation only requires the Linux or Ubuntu based servers. You cannot install the Docker engine on the Windows machine. No. Docker engine only support natively the Linux and Ubuntu servers, and this is a library. So you need to install the Docker engine library on the Linux or Windows servers. Once you have the Windows and Ubuntu based servers, if you are using the Linux or you are using the Mac operating system, then you can easily connect with the server using the SSH, right? You can SSH the server from your terminal, Linux terminal or the Mac terminal. But if you are using the Windows operating system, then you cannot SSH your server. And to SSH your server, to make the SSH connection with your server, by which you can connect with the server CLI, you need to some kind of SSH tool like Putty or MOBA Exterm to connect with your server. So if you will go to the browser, so these tools are only required if you are using the Windows, right? And you want to connect with your server. So you see, if you will search for the Putty, then you can see you can download the Putty. And what is the definition? Putty is a SSH and Telnet client. You can download it and you can use it. Otherwise, I will prefer, this is a very nice tool to connect with the servers or make the SSH connection. And you will get a UI like this, which is a very interactive UI. So you can install either of the tool, Putty or MOBA Exterm, if you are using the Windows operating system and you want to connect with your servers. Here to create the Linux server, you can use the any cloud provider. If you have your account with the Microsoft Azure, GCP or AWS, you can use your preferred cloud. But we will be using the DigitalOcean cloud, right? We will be using the DigitalOcean cloud. And what is the reason that I'm using it? Because to use the DigitalOcean cloud, you need a very little knowledge of the cloud technologies, right? You just spin up a server and you can connect with it and you can do whatever you want. You don't need to care about the network security rules, security groups, IAM rules, and there's a lot of things which comes in a picture once we are going with the AWS, Azure or the GCP. So we will simply use the DigitalOcean, which is the simplest public cloud, and we will create a server on the DigitalOcean. Because this is a paid cloud provider, so what I will do, I will provide you a $200 DigitalOcean coupon. Using that coupon, you can create the machine and you can use the DigitalOcean for 60 days, right? How you can get the coupon? So in the next lecture, I have prepared the instructions. You need to follow these instructions. If I will open the next lecture, you can see the instruction will look like this. So you will get this next lecture, 200 credit for the DigitalOcean to create the Linux server. Over here, I have provided the promo link to get the $200 credit. Once you will click this link will redirect you on the DigitalOcean cloud. And over here, you are getting a message, free credit active. Get started on the DigitalOcean with $200 60-day credit for the new users. You just need to sign up and create a new account. And these $200 credit will be credited in your newly created DigitalOcean account. Later in the coming lecture, we will see how we can create the machine with the DigitalOcean. As a part of this lecture, what you need to do, you need to sign up and create an account on the DigitalOcean. Thank you, team. See you next time. Hello, team. Welcome back. And as we discussed in the previous lecture, that we need a server to install the Docker engine. If you are using the GCP, AWS, or Microsoft Azure or some other cloud, then you can go and create a server on your public cloud. If you are going to use the DigitalOcean, then we will see that how we can create the Linux server on the DigitalOcean. In the last lecture, I have already provided the $200 credit code. So I believe every one of you have created the account with the DigitalOcean to avail that $200 credit. So let's go to the DigitalOcean and see how we can create the server. So open the browser and search for the DigitalOcean, and you will get the DigitalOcean official link, www.digitalocean.com. Let's click this. You have created the account, so click on the login button and log in your account. So once you will open the DigitalOcean, you will get a UI like this. Over here on the top of it, you are getting a create option. I will click it, and over here you are getting a droplet, create cloud server. I will click this link. Once you will click this link, you need to choose the data center for your server. I will go with the default data center. No need to change in the network. I will go with the default network. Choose the machine type. You can choose any machine type, whatever you want. I am going with the Ubuntu. Choose the version. So latest version is available, Ubuntu 20.10. I will go with the latest one. Over here you are getting the droplet type. If you want, you can use the shared CPU or you can use the general purpose CPU. But shared CPU is a cheaper compared to the general purpose CPU or any other CPUs. So we will go with the shared CPU and we will go with the regular SSD. See, here we are getting the different machines. Like if we will go with the $12 machine, then we will get the 2 GB RAM and 1 core CPU, 50 GB SSD. If we will go with this, we will get the 2 GB and 2 core CPU. Because we have the $200 credit in our account, so we can go with any of the machine. Let's suppose we are going with the $18 per month machine or $24 per month machine. Let's select this. Here it is asking to authenticate. If you want to authenticate your machine with the SSH key, you can use it. Otherwise, I will choose the password based authentication. Over here, as per the password instructions or password requirement, you need to type your password. I have typed my password. From this icon, you can also see that what is the password you have typed. You need to remember this password because this password you need to use to SSH this droplet once it will be created. Now here few more options. Let me avoid all these. Here we are getting that how many servers we are going to create. We are just going to create one machine, and let's rename the host name. I will take it Docker machine, right? Let's click on the droplet. Shortly your machine will be ready. Let's wait. So the droplet is ready, and over here we are getting the IP. You can use this IP to SSH your machine. If you want to SSH using the IP, you can use it. Otherwise, DigitalOcean provide the browser based access as well. Let's click this three dots over here, and you can see we are getting the option access console. Open this access console, and over here it is asking login as root, launch droplet console. Click on it. What it will do, it will open the CLI of your server in your browser. So you will be able to access your machine from your browser. You don't need any SSH tool, or you don't need to use the SSH from your Linux terminal or the Mac operating system terminal. You can directly access your machine from your browser. Let's wait until the console will be ready. So you can see the console is ready. We are getting the machine information. This is the name of my machine, and this is the IP of my machine. This is the IP of my local machine from which I'm accessing this droplet. So this is the way, team, how you can create. So team, this is the way how you can create the DigitalOcean machine and how you can access the DigitalOcean machine over the browser. If you want to access this machine over the SSH client, you can use the SSH tools. But I prefer to use the browser because over here I don't need to type the passwords again and again. Hello team, welcome back. And in the previous lecture, we have seen that how we can create the server, right? So if you are using the DigitalOcean, you can follow the instruction which we have used in the previous lecture and create the server. If you are using some other cloud, then you can create your server and follow the instructions which we are going to do today to install the Docker engine on the Linux server. So today we will see how we can install the Docker engine on the Linux server or the Ubuntu server. So we will go to the DigitalOcean machine which we created in the earlier lecture. So here we are on the Docker machine, right? This is the machine we created in the DigitalOcean in the previous lecture. I will clear out the console. But we also need to know that what is the steps we need to follow to install the Docker engine on the Linux server. So we will go and open the docs.docker.com. This is the official Docker document site. Over here we are getting the option to download and install. If you will click this in a new tab, here you will get the option to install the desktop only. You are not getting any option to install the Docker engine. To install the Docker engine, we need to go to the manuals, and in the manuals you are getting a link Docker engine. Let's click on the Docker engine. Over here you are getting the install. Go to the install, and in the install you can see we are getting the different kind of installation. Install for CentOS, Debian, Fedora, RHEL, SLES, and Ubuntu. We created the Ubuntu based machine, so we will go to the install on Ubuntu. Here you can see this is the prerequisite of your operating system. It needs Ubuntu 22.04. What is the Ubuntu version we installed? We installed Ubuntu 22.10. It means the operating system which we used is not compatible with the Docker engine, right? So we need to recreate the Docker machine. So what I need to do, very first I need to destroy my Docker machine. So click on destroy this droplet, and I will create a new droplet with the compatible operating system. We are already aware with the steps, so I don't need to explain each and everything again and again. I will just choose the Ubuntu 22.04 long time support version, fill out my other details, and click on the create. So you can see the machine is ready. We will access this machine on the console. So we will again click this option access console and launch the droplet in a console. So this is the correct OS version we have installed, which is Ubuntu 22.04 long time support. Let's wait until we will get the connection with the machine. So the server is connected. You can see this is my 22.041 LTS long-term support of Ubuntu Linux 5.15. This is the IP of my server. I will clear out the console. Let me maximize the font so that we can see the commands clearly. Now let's go back to the documentation. In the documentation, it is asking to install the old version because we created the server very first time, so there is no old version available, so we will skip this command. Scroll down. Now it is saying first we need to update the apt package directory. So we will copy this command and execute over here to update the apt-get package directory. Apt-get is a package manager in the Linux. This is done. Now we will go to the next command, and over here you can see it is installing few package: CS certificate, curl, GNU-PG and LSP release. So I will copy this as it is, clear out my console and put this command. Hit enter and it will install all four packages. Whenever it will ask, you need to provide your confirmation by provide y, hit enter and the installation is done. Clear out the console and the next step it is saying add Docker official JPG key. So I will copy these commands and execute here. Hit enter. This is done. Next it is saying use the following command to set up the repository. I will copy this, put it here, hit enter. This is also done. After this it is saying install the Docker engine. It is again asking to update the package manager. Why it is asking to update the package manager? Because we have done some changes in the repository and the JPG key. So once you will update the package manager, it will download the package which you have updated in your registry or directory. This is done. Now copy these commands and execute these two. And after then it is saying install the Docker engine, containerd and the Docker compose. And this is the command to go with the latest one. If you want to choose any specific version, you can use this. I'm go with the latest one. Copy this, put it here. So it is installing the few things. First, it will install the Docker CE, which is Docker Community Edition. Then it will install the Docker CE CLI Community Edition command line interface, containerd.io, which is a container daemon process, and Docker Compose plugin, which is a Docker Compose for the multi-container environment. Hit enter. It will ask for your confirmation, provide your confirmation and hit enter. It will take some time and shortly you will see the Docker installation will be done. See, this is done. Clear out the console. Now to verify your installation, you can execute the Docker run hello world. What this will do? This will basically execute the hello world container on your Docker environment. So I will execute it. It will basically download the image and it will execute the container. The container execution is done. This is the ID of your container and this is the message which your container being printed, hello from Docker. If you want to see, you can clear out the console and execute a command docker ps-a. This will list out all the containers either in the running state or in the exited state on your machine. So see, this is a container which is exited 30 seconds ago. The image name was hello world and the container name was Solid Hover. So the installation is done. If you want to verify the version of your Docker, you can install Docker version. Hit enter and Docker version 20.10.21 is installed. Right. So team, this is the way how we can install the Docker desktop, how we can install the Docker for the servers. So we have done the both kind of installation. Going forward in this course, we will use the server side installation as well and the local installation as well. I mean to say the Docker desktop and Docker engine both. Why? If you want, you can use anyone. Either you can use the Docker desktop completely or you can use the Docker engine completely. Right. But I want to use the mix of these so that I can show you that if you want to work with the servers, what are the Docker commands you need to use? And if you want to work with the desktop as a developer, then what is the commands you need to use? So the command is going to be the same, but at least you will get some practice that how you can work with the server and how you can work with the Docker desktop. So that's we are going to use both of the flavors. Thank you team. In the coming lecture, we will start learning the Docker basics. Thank you. Hello team, welcome back. Previously we have discussed how we can do the installation and we have done the setup of the Docker desktop and Docker on the Linux server. Now we will start with the Docker, right? We will start with the Docker functionality. First we will check the installation, then we will check the configuration, and we will start learning about few commands in the Docker. So as of now, we are not going to use the Docker desktop. We will use the Docker on the server. So we created the DigitalOcean server and we installed the Docker on it. So we will use that particular server machine for the few next lectures. Once there is something which I need to show you on the Docker desktop, I will show you on the Docker desktop. But for now, we are going to use the server. So what we will cover as a beginner, as of now, we are beginner in the Docker because we don't have seen the Docker, right? I'm not sure if you have some experience in the Docker, but I'm assuming that the people who are learning this course, they are beginners. So what we will cover as a beginner? Very first, we will learn about the containers. What are the containers? How we can initiate the container on the Docker? We'll check out the versions of the Docker and the Docker CLI, and then we will learn about the container management command. So to execute the stuff on the Docker, you need to use the Docker CLI. So you need to be very specific about the commands. The command should be on your tips, and these are the command which you will be using while you will be working with the Docker. So let's start with this. So very first we will verify the version of the Docker installed on our machine. So as I told you, we will use the server side machine. So team, here I have opened my server side machine, Docker machine, where we installed the Docker. So let's check the version of a Docker using a command docker version. Hit enter. Once you will execute this command, you will get a two kind of output. Very first, we are getting the output of the client, right? Second, we are getting output of the server. So what is this client and what is this server? So you can see this is the client of the Docker engine community and this is the server of the Docker engine community. So client is Docker client. So if you remember, while we was installing the Docker, we have installed the Docker C, Docker CLI, Docker containerd, and there was few more libraries. So this Docker client is a Docker CLI, the command line interface which will interact with the Docker engine. And this server is a Docker runtime environment, right, which is actually executing the Docker. So this CLI Docker used to communicate with the Docker server, and this server is the actual Docker server which is executing or which will execute your containers. So the version what we are using as of now is 20.10.21, API version is 1.41, and the same version of the server we are using and the same API version of the server. So this is the client version and this is the server version. It doesn't matter that you are using some different version of the server and different version of the client. You can do that as well, but generally I prefer to use the same version client and same version server. So that is the reason I have not specified any specific version while doing the installation of my Docker. Clear out the console. And next thing is verify the Docker engine setup and detail. And you can verify the Docker engine setup and details using the command docker info. So we will execute the docker info, hit enter, and here we are getting few details. You see we executed a command docker info. So this is the use of Docker CLI. This is the Docker CLI by which we can get the output from the Docker commands. What is the output we are getting? That this is the client, the context, the plugins which are available, and we are getting the output on the server. These are the number of containers which are available on the server: running state container, paused state container, and stop state container. Also we are getting the number of image which is available on this server. Then we are getting few other details like the C group, logging drivers, volume, and there are few more details available for the server. So at any point of time, if you want to get the detail of the Docker server, that what is the state of my Docker server, you can simply execute this command docker info, right? And you will get all the relevant details, whatever the details you want to know. Clear out the console. Let's move further, and next we will understand a command docker. So if you will list out all the Docker commands, you don't know that what are the Docker commands available for the Docker, right? And few commands comes up and few command modify during the version upgrade of the Docker. So you don't need to remember each and every command. If you want any kind of help, you can simply go to your Docker and type a command docker. This will list out all the available commands on the Docker. So if I will simply execute the Docker over here, hit enter, see, we are getting a lot of commands. Let's understand them. So here we are getting the use, how we can use the Docker command. So Docker command always start with a keyword Docker, then we have the option, and then we have the command. What are the options do we have? Options we have config, context, debug, host, log level, and -v. These are the shortcuts which are available. These are the abbreviation, and here you are getting the description of these options. So you can go through these options to understand it much better. Now, few other commands are there. One is a management command and another one is a commands. So what are the management command? So management commands are basically used to manage the Docker, right? Where you want to manage the containers, whether you want to manage the services, swarm, or configuration, you need to use the manage command in that case. Now we have the commands. Whenever you want to perform some kind of operations, you use the commands like attach, build, commit, cp, create. So these are the commands, and in front of the command we are getting the description of each and every command, right? In front of the command we are getting the description of each and every command. So this is the this is the thing, this is the help you can prefer. If you don't remember the command, you can simply type the Docker and you will get the complete list of the command with the details, that what is the detail, what is the purpose of that command, and how you can use it, right? If you need some more help about a command, you can type Docker, then type your command, then hyphen help. So let's understand it. Suppose we want the help of the image. So what we'll do, we will type Docker image help, hit enter, and see, we are getting the complete help details or the commands which are available for the image. For the image we have these commands available. We are getting the command, we are getting the description of that command, right? So this is the another way how you can get the help on a specific command. If you don't know that what are the options do I have with the management command, you can use it. The another thing is Docker management command format. So whenever you are executing some management command, what you need to do, you need to execute the Docker, then you put the management command, and then you need to put the sub command. What is the sub command? Let's go to the terminal again. Let's take this example. We execute it. So this is the main keyword which we need to use to execute the Docker command. This is the management command. We have seen that there are few management command and we have chose one of them. Once we ask for the help, it is saying that after the Docker image, we need to perform some command. And what are these commands? These are these commands. Let's perform someone. So Docker image, and let's perform the history. This is the command. So you can see it is saying that Docker image history requires one argument. So basically this can define the history of the image, but it also want to know that for which particular image I want to go with the history. In the similar way, let's go to some other command like Docker container. So we will clear out the console. So this is the main keyword. This is the management command. Let's type help. And these are the commands which we can execute with the Docker container command, right? Run rm start. So whenever you will execute any command like Docker container, and after this you will put any sub command like we will put ls, what it will do, it will list the containers. Hit exit, hit enter, and we are getting nothing. If we put -a after this, hit enter, then we are getting something. So with the option of -a, we will get the all containers available. But with the command Docker container ls, we will only get the running container, because we don't have any running container, so we are not getting anything over here. Similarly, if you want to perform some other command like Docker container run or Docker container restart, let's perform restart. If you will execute this, you will get an error. See, we are getting error. It is saying that the format is Docker container restart. You need to provide the option and you need to provide the container name as well, that which container I want to start. So this is the main command, this is the sub command, and after this you need to provide some kind of argument which is accepted by that command. So this is the flow and this is the syntax of the Docker commands. I hope you are getting my point, and now you are understanding that how you can execute the Docker command on the Docker. It doesn't matter you are using the Docker CLI, which we are using on the Docker server, or you are using the CLI on the Docker desktop. The behavior will be same. But I prefer to explain you the things on the Docker server because this is the actual working place where you will be doing the things on the production. So we have seen few basic things. In the coming lectures, we will see few more things about the Docker container. And team, in the coming lectures, you will see a mixed kind of lecture. Few lecture will be the new lecture and few lecture will be the old lecture which I created earlier or which are already the part of the existing course. Where I feel the need that I need to update that lecture, I am updating these lecture, but where the lectures which already have the perfect content or the usable content, they will be untouched and they will be remain the part of the course. So it may possible sometime you will get the execution on the different machine, I mean to say the white terminal machine, sometime you will get the execution on the black terminal machine. So don't get confused, the command will not change. Whatever the command I'm executing, you need to perform the same commands, right? Just the machine will be changed because few are the new lectures and few are the existing lectures. So thank you team, see you next time.
Hello team, welcome back. Welcome to the Docker for DevOps training, and in this particular lecture we will learn about the containers. So today we will see how we can execute or start our first container. So let's go through the lecture. So let's see what we are going to cover in this particular lecture. Very first, we will discuss about the images and containers. Then we will see how can we execute the containers inside the Dockers. After that, we will see how can we check the container logs and processes. So these are the three topics we are going to cover in this particular lecture. Let's start with. So first we will discuss images versus containers. But before going to start with the images versus containers, I would like to explain why containers required. So what is the application of the Docker? Why we are using Docker technology? Why Docker is using container technology? And what is the images? So we have 3 points to discuss. The very first is the Docker, the second is container, and third is image. So basically, we all are aware if we are learning the Docker course, then I'm sure we are from the technical background and we are working as a freelancer or we are working in some kind of IT organization. So every one of us know that in the IT industry we are working on the softwares, and a software is not a single unit, it's not just a source code. A software is a package, right? A software is something which requires a lot of library, which requires a lot of tool set, which requires some kind of dependencies, right? So when we are moving forward, so when suppose we are running a application on the production, right? So you are a developer and you have created some application, right? That application requires some kind of dependencies. That application required a specific environment to execute. That application required some other binary to execute on it, right? So you need to add these dependencies, you need to provide that binary to your application, and you need to set up a complete execution environment for your application. But if you want to ship that application to your customers, suppose this is a hosting application, or this is something you want to uh, execute that application over the cloud machines, right? So you need to move all the dependencies, all the binaries on the cloud machine, plus you need to set up a complete execution environment for your application on the cloud machine. With the Docker, we minimize this effort. With the help of the Docker, we create an executable image of Docker, right? So image is basically a executable format. When we are saying we need to start your application, we need your source code, we need the binaries of the other applications, we need some kind of dependencies, we need some kind of execution environment. So a image is a package of all these things, right? So image is package of all these things, and containers are required to execute that image, right? So what is image? So basically, image is the application we want to run.
right? We just want to run our application, but it has a lot of dependencies on other applications as well, and it needs a particular execution environment. So with the help of the Docker, we will create an executable image that can contain the application binaries, source code, dependencies of the other applications, and dependencies of the execution environment, right? With the help of the Docker, we will execute that particular image, and the process which is executing that particular image is called the containers, right? So now we are pretty much clear about all these things. So image is something which is an executable format of your application, right? Container is something which is executing that particular image, or it's an running instance of that particular image, and Docker is something which is providing the execution environment to that container, right? So it solves all our problems. So we just need to set up a Docker, and we will execute a single command to start your application. We don't need to provide any runtime dependencies. We don't need to set up any kind of execution environment to before start your application. We have wrapped up everything inside an image, and container is basically carrying that image, right? So what are the Dockers, containers and images? So images is your application which you want to run, right? And in the Docker image, we include all the things like all the dependencies, all the binaries, all the executables, right? And container is a process, or we can say a running instance of your image. And Docker is something which is running that image, right? So I hope this is pretty much clear to everyone. What is the Docker, what is container, and what are the images, right? Let's move on. Okay, you can have many containers running the same image. Yes, suppose you are running your image over the cloud and you have created a cloud machine which have a lot of capacity, right? Which is running over 32 core bit operating system, right? Sorry, 32-bit 64-bit operating system, and which have the 32 CPUs, right, which have a lot of RAM. And on that cloud machine you can create, or you can start your application 5 times, right? So in this way we will create 5 containers of your images, right? A container is a running the same image multiple times. So every time container will run your image, it will create a new container itself, right? So on the same hosting machine, you are creating the 5 containers of the same images. It means on the same hosting machine, your application can execute 5 times, 5 folds with the same image. It means on the same hosting machine, you are executing, or you are serving 5 customers. Suppose if your one instance of your running image can serve 1 customers, right? So with the help of the multiple containers, you can serve 5 customers at the same way on a same hosting machine. In this lecture, we will use open source nginx web server, right? Before going to start with the nginx web server and other stuff, I would like to explain something about the Docker central repository, which is hub.docker.com. So let's go to the hub.docker.com and we will discuss about the Docker central repository. So right now I am on hub.docker.com, and this is the first page which will open when you will hit the URL hub.docker.com. Over here, if you don't have your account on hub.docker.com, you can sign up and create your account. If you have your account, then you can click on the sign in button on the right top corner and enter your login credential to insert or to go in inside the hub.docker.com. So I will enter my login credentials. After the successful login, you will land on your dashboard. So I have already published some images so that I'm getting a UI like this. Once you will fresh create your account, you will go to your dashboard, you will not get anything over here. So this is the central repository of all the Docker images, right? So hub.docker is the central repository of all the Docker images. You can either create your private account or public account. You can either publish your private image over here or publish image over here. So if you are from a development background, then you can relate it with the Maven central repository, where we have all the dependencies which is required for the Maven application, right? In the same way, let's understand this with the very layman term, right? So hub.docker.com is a repository where we can push our Docker images, or we can find out any public Docker images, right? So hub.docker.com is a central repository for the Docker, right? For the Docker community. So you will find out all the images which you want to execute, and that should be public. So either you can create your own public image and push it over the hub.docker.com so that you and other people can also use it, or you can create your private image and you can share the details with your customers and with your development team so that they can also use it, right? So suppose you want to search for some kind of image. So there is a basic image of the docker.com of the hub.docker, which is hello world, right? So we are getting a lot of images of the hello world, you can see over here, right? But the official image always have the subtext like official over here, right? So this is not the official, this is automated build, this is also automated build, and over here we are getting a different kind of naming convention. We will discuss about the naming convention in the coming lectures. Today we will see what are the images and what is all about the hub.docker.com. Once I will click this link, it will open the page of the hello world repository, and over here I am getting all the commands and all the useful information about this hello world, right? So if I want to pull this image in my local, then I can execute the command docker pull hello hyphen world, right? If I want to execute it, then we will see what commands we can execute. A sample output is here. If you will execute hello world, then you need to execute the command docker run hello-world, and it will display an output like this, right? So this is the very first image of the Docker, which you also can execute to verify that your container is running or not. Sorry, your Docker is running or not, or your Docker is able to execute a container or not, right? So let's open the terminal so that we can open our containers. For open the for open the Docker, I need to go to my cloud machine. So I will SSH my machine, enter my password, and right now you can see I'm inside my Docker machine. I clear out the console and increase the font a bit, right? Now suppose you execute a command docker info. We have already discussed about the docker info in the last lecture. It is saying we have 0 containers, 0 running containers, 0 post and 0 stopped. Also we have the images 0, right? I will clear out this console, and suppose I want to execute the container hello world. So what was the command to execute the container hello world? So command was like docker run hello-world, right? So I will open this command, execute this command. So I will execute the command docker container hello-world. Press enter, and it is saying, okay, I forgot to insert the sub command. See, the manage commands I inserted, but I forgot to insert the sub command. Enter the command docker container run hello world, and you can see over here the output. So over here we have executed the command, right? Docker container run hello world. So first the message is unable to find the image hello world latest locally. So very first, when you will start any container, the Docker will search for that container image in your local machine. If it will not find out that image in your local machine, you will get a message like this, unable to find image name and locally. After that, it will pull the image from the hub.docker repository, right? So if the image which you want to run is not present in your machine, then Docker will pull out that image from the hub.docker repository. You don't need Git or anything installed in your machine. Docker will pull out the image by itself. And here is the digest and pull ID, right? After that, you can see it has executed your image, right? Clear out the console. And now if you will execute the command docker info, you will get a different output. Over here, you are getting containers are 1, running 0, stopped 1, and images 1. So basically, we have already executed a container, which was the hello world. It executed itself and come out, right? So that it came in the stopped state. And we have the image 1. So hello world image is basically downloaded in my machine, which my Docker just executed in the last command. Suppose I will execute the same command again. I will execute docker container run hello world and press enter. This time I didn't get a message image is not present locally because the hello world image is already present in my machine. So it didn't downloaded the latest image. It find out the image in the local and it simply executed it, right? So this is the image hello world container which is executing the process, and Docker is the engine which is executing or which is providing the execution environment to the container. So we have seen and discussed about the hub.docker.com, and we have executed our first image hello world. Let's move to the next slide. So we have already discussed about the hello world. So we are going to skip this, start with hello world Docker image. We have discussed about this thing. Now we will see start nginx web server in Docker. So very first I will go to my hub.docker.com and I will search for the nginx image. And if the nginx image will be available on the hub.docker.com, so that I can download it and execute it. To execute the nginx image, I need this particular command, right? Which is docker container run hyphen publish the host port colon container port and the image name, right? So this is the command which we need to use to start the nginx on my Docker. So let's discuss about this, or first we will start the container, after then we will discuss about this command. So let's move to the image. So first I will go to my hub.docker.com and I will search for the nginx image. So you can see nginx official image is available on the hub.docker.com and it have 10 million plus polls plus 9.5k stars. I will go to details and here is the all details available for this particular image, right? How we can use it, how we can execute it, and all the stuff we are getting over here, right? So if you want to learn about the image, let what that image is all about, what it is doing, then you can go to the image description or image details, and if the the user who has published that particular image has provided the enough details about the image, so you will get all the details on that particular details page. So all about the nginx we are getting all the details over here, right? So this is your task for your homework. You can go to this particular image page and you can learn about all the configuration and variables and all about this nginx image, so that you can understand what all this all about, right? What is the meaning of this particular, so you can learn about what is all about the images and image description, right? So we are going to start the nginx and we know that our image name is just nginx, right? So I will go to my terminal, clear out the console, and I will execute the command docker container run publish host port, which is I'm providing 80, colon container port, which is also I'm providing 80, and the image name. Let's discuss about this particular command. So Docker container run is a command which we can use to run a container. We have already discussed that. What is this? This is something new, hyphen hyphen publish. So hyphen hyphen publish we use when some of the application is using, some of the applications are the web applications like, and they are using some kind of port, right? User needs to enter some kind of port after the URL to access that particular application. So to expose the port over the internet or over the browser, we need the publish command. And host port means this 80 is the host port. Host port means the port which will open on the hosting machine which is executing the image. And after the colon, we will provide the container port. Container ports mean the port which container will open to route the traffic to the application, right? So by default, Nginx use 80. So the container port should be 80. But this port, the host port, is not limited. You can provide any port over here because this is the port over which the application will be accessible on the hosting machine, right? So let's start the Nginx container. Once I will hit the enter, it printed a message unable to find the Nginx latest image. Now it is downloading the image, and after the complete download, it will start at the Nginx. Now you need to go to your browser, right? Open a new tab, and remember, if you are using your local machine, then you need to hit the URL localhost port 80, right? But as and it should open your Nginx web page. But if you are using your Docker on a cloud machine like us, then you need to enter your IP address. Like my IP address is 159 dot, let me find out the IP address, 159.89.142.80 colon port 80, because we have started our Nginx on port 80, right? So we can see this is the IP of my machine, right? Of my Linux cloud machine, because my Docker is running on my Linux cloud machine. So I need to open this particular IP and this particular port. Once I will hit enter, it will open the Nginx web page, right? If you are running the container in your local machine, then you need to hit the URL localhost port 80, right? So as soon as I will hit this particular port, there should be some kind of log generated on my machine. See. So in the background, I have my terminal, and over that I have my browser. Once I will refresh my browser, it will generate the logs on my terminal. See, every request I'm refreshing my browser, some logs are being generated on my terminal. So these are the container logs. You can see over here the date, the request, which is a get type, and the proxy which is being used, right? So every time I will refresh my web page, a new log being generated over here, right? So if you want to, you can see over here your terminal is, or your container is basically running on the foreground, right? Now suppose you want to exit out your container, then press Ctrl C and you will exit out of your container. Now if you want to access your Nginx web server, you will not get to access it, right? Now we have seen the use of Docker container run, publish, host port, container port, and the image name. Let's discuss what all the processing is being done behind the picture. So the process was done first when we executed the nginx start command, then first is downloaded the latest nginx image from the Docker Hub. Then it is started a new container, right? Exposed the container port 80 on the host machine and route the traffic on port 80 inside the containers, right? So this is all the process we have done in the above command. We have seen if we want to stop the container on the foreground, then we need to press the Ctrl C. Now there is a new challenge. Suppose we want to execute the container in the background, right? Or in the detach mode. Why this requirement comes? Suppose you are using your container, right? You are using your web application, or you are using some kind of proxies which you want to run until you want to stop that forcefully, right? So in that case, if you are using your terminal to execute these containers, so once you will log out your machine, it will stop the process, right? So you want to execute this process in the background. To execute the process in the background, we need to append the detach hyphen detach before the image name inside your command. So let's see. So I have opened my terminal and I will execute my last command. But before the image name, I will put hyphen detach, detach. Press enter and it will return you the container ID. That's it. And suppose you want to check, then you need to go to your browser and refresh this URL, right? And you are able to access your nginx on port 80, right? Now suppose you want to start a same nginx image on some other port like 8081. So you can do this, right? All the traffics inside the containers are using port 80, but on the host machine we can open the application on different port, right? It also return me the container ID. Once I will go to my browser, right, and I will open another port, and over here I will enter the IP of my address. Sorry, I will enter the IP address of my machine. If you are using the containers in your local machine, then you can provide the local host over here and then the port. New port is port 8081. Press enter and we are able to access the nginx application on both of my port, on 8081 and on 80 as well. And you can see both are basically on the same host machine. So this is the beauty of the Docker, right? You can't do this with the help of the VMs. You can't do this with the help of other hosting applications. So suppose you are not using the containers, you are executing this particular application on your machine, then once a port is basically preserved by any application, the same application can't be run on the second port on that particular same machine. But with the help of the Docker, we can execute them. You can see the same application running twice on a same machine, right? Now, so we have discussed about the detach mode. Now suppose you want to list all the running containers on your machine, right? So how can we do that? So for this, we need to execute the command docker container ls, or you can execute the command docker ps. So Docker PS is the old way, right? So as we are working on a latest Docker, right? So we need to follow the procedure like command, then manage commands, then the sub commands. Like Docker PS is the old command. Altogether it will work, but the new command which we should use is Docker container ls. I will move to my terminal and I just started two containers, one on port 8080 and another on port 8081. I will execute the command docker container ls. There's a typo in my docker spelling. See, we are getting the two running containers. This is the container ID, the image name, the command which is executing, and the time when this container was created and the status, that, and the port on what the container is running and the name of the containers, right? So we are executing, or we are running two containers. There are two running containers on my machine. One is with this container ID, another one with this container ID. One container is running on port 80 and another container is running on port 8081, right? Let's discuss about this name. So we didn't provide this kind of name, right? We didn't provide this kind of name. So from where these particular names are being picked? So basically Docker can pick the application, or sorry, the container name from its own directory, from its own dictionary, right? So it can randomly choose any name and it will assign that name to a container on your machine, right? If you will execute the another command or the deprecated command like docker ps, it will also do the same thing, right? But we should go with the latest commands because we are working on the latest technology of the Docker. So I hope that's all for the day. In the coming lectures, we will learn about the how we can stop the running containers and how we can remove the containers from the Docker. Thank you guys. Thanks for your time. Hello team, welcome back. Welcome to the Docker for DevOps training. And in this particular lecture, we will discuss how we can stop, remove the containers from the Docker. So let's start with the lecture. So in the previous lecture, we have discussed how we can execute or how we can create, how we can run our first containers, right? We have seen some more commands about the containers, right? We have seen about the hub.docker.com, the central repository of the Docker. Today, we will discuss how we can stop the containers because till now we have just seen how we can start the containers in a foreground mode and in the detached mode, right? So we have started two containers yesterday in the detached mode, but suppose if we want to stop these containers, then what is the way, right? So to stop the containers, we have a simple command docker container stop, then you need to provide the container ID. So let's start with the commands. To start with the Docker commands, I need to SSH my remote machine, my remote Linux machine where I've installed my Docker. So I will open the terminal and SSH my machine. So you can see I'm inside my Docker machine. I will clear out the console. If I will execute the command hostname, then this will return me the host name, and I know my remote machine host name is Docker. So yesterday we have executed two containers. So suppose we want to see the running containers on our Docker. So I need to execute the command docker container ls, and you can see the two nginx containers are running since last 30 hours. So we have created and executed these containers in the last lecture, but we didn't stop these, right? So suppose you want to stop the container which is running on port 80, right? So first let's see if we are able to access the nginx on port 80. So I will open the browser, and as we discussed in the last lecture, if you are running the Docker in your local machine, then you need to insert localhost colon port 80, but I'm using a remote machine, so I need to put the IP of my remote machine, then colon port 80. So on port 80, I'm able to access the nginx, right? Now we will stop the nginx container on port 80. So for this, I need to execute the command docker container stop, and then I need to provide the container ID which I want to stop, right? So suppose I want to stop this container, so I will simply provide this container ID and press enter. Oh, there was a typo error in the docker command, so I will correct it. The command is docker container stop, then the container ID, press enter, and you can see it is returning the container ID. Now if I will execute container, sorry, docker container ls, then it will return you only single container which is running on port 8081 because we have stopped the container which was running on port 80. If I will go to my browser and refresh it, then I'm not able to access it. But if I change the port to 8081, see, on port 8081, I'm able to access my nginx container because on port 8081, my nginx is still running. So this is the way how can we stop the containers in Docker, right? Now, suppose you have a requirement, then you need to list down all the containers, although they are running or they are stopped. So how can you basically list out the IDs of all the containers which have executed on your Docker? For this, we have a command docker container ls-a. So let's execute it. So we are on our terminal. We will execute the command docker container ls-a. And you can see I'm getting a list of containers. So basically these are the containers which we have executed inside this Docker engine so far, right? So only one container is running. The latest one, nginx, is running on port 8081. Rest all of the containers was exited or stopped. So suppose you want to find out the containers which has been executed on your Docker engine, then you need to execute a command docker container ls-a. This is the command to list down all the containers which have executed on your Docker engine. But if you just want to list down the running containers, then you just need to insert the command docker container ls, and it will list out only the running containers. Now we will discuss about run versus start commands in the container. So till now we have only discussed about the run command. So basically when you want to execute a container, you need to execute a command docker container run, then the image name, right? Then what is the meaning of the start command? Why we use start command in the Docker? So we always use run command in the Docker when we need to execute a new container, right? Run command will always start a new container. But suppose you want to start an existing container, right? Then you need to use the command start. Let's see how we can use start command. So we are on our terminal, right? And 2 minutes before we have stopped this container which have the ID 27E6C07981AE. So we know very well 2 minutes before we have stopped this container, and this container was running on port 8080, right? So suppose you want to start this container, then you need to execute a command docker container start and then the container ID, right? So I need to provide this container ID. Press enter and it will return you the same container ID, right? Execute the command docker ls, sorry, docker container ls. And you will see two containers are running, and the second container has the same ID which was stopped 2 minutes before. So with the help of the start command, you can start the existing container on your machine. But if you will execute the image or the container with the run command, it always start a new container on your Docker engine, right? Sometimes the start command is helpful, sometimes the run command is helpful. We will discuss all the scenarios in this particular course in the coming videos. Now let's move to the next slide. So we will discuss about the containers names. So suppose till now we have seen my containers have some specific name, and suppose I want to provide some kind of meaningful name to my container. Then how can I provide a meaningful name to my container, right? For this I can use the command docker container hyphen public host port container port hyphen detach hyphen name and then provide the name. So all the command is same we have used earlier. Just one parameter is extra in this particular command, which is hyphen name, right? So let's see how can we use this particular parameter. So till now we have seen our containers have some kind of names. So my first container have some kind of elastic permal, right? My second container is also have some name, my third container is also have some name. So there is the names of the container, right? Suppose they all are nginx. This nginx is running on port 8081 and this nginx is running on port 80, right? We have stopped this container. Suppose we are going to stop the container which is running on port 8081. So docker stop, sorry, docker container stop, then the container id, which is this, right? Container is down. Execute the command docker container ls and you will see only one container is running which is on port 80, right? Clear out the console and execute the command docker container ls space -a. It will list out all the containers which was executed on this particular Docker engine. Now somebody will ask you which container was running on port 8081. So by this particular information, you would not be able to define which container was running on port 8081. So sometimes you need you need to name the containers with some specific string. So in this way, we will see how we can name the container, right? So when we have a requirement to provide some kind of custom name to my container, so we can use the name property of the Docker container. So let's see how can we use the name property of Docker container. For this, I'm going to start a new container on port 8081. So we will start with the command docker container run hyphen hyphen publish to publish on the host port and the port should be 8081, then define colon, then container port, then detach to execute the container in the background space. There is a new parameter what I'm going to insert hyphen hyphen name and I will name it anything what I want. So like I'm going to name it web host 8081, right? Then the image name what I'm going to run. So I'm going to run the nginx. Press enter. So you can see a container is being executed. If I will execute a command docker container ls, so it will provide you the list of running containers and you can see the name is the name which you have provided to execute the container, right? So this is the property of the name command. With the help of the name, you can provide the custom name to your containers. Now suppose you want to see the logs of a specific container, then how can you see the name of particular container? For this, you can execute the command docker container logs, then the container name or container ID. So let's see how can we get get the logs of the containers. So suppose we want to see the logs of a container which is running on port 8081. So for this, suppose we are going to generate some logs. So I will go to my browser and refresh my nginx container again and again, right? So I have refreshed it three times. Now I go to my terminal and execute the command docker container logs. Then either I can provide the container ID, which is this, or I can provide the container name, right? So I'm going to provide the container name. If you want, you can also provide the container ID. Press enter and it will list the latest logs generated on your containers, right? So right now the 4 lines of logs are being over here. I refresh it 2 more times. Again go to my terminal and execute the log command for my container. Now I will get few more lines. See? So using this way we can get the logs of a container, of a running container, right? Now we will discuss another command docker top. So suppose you want to see the running processes inside your container, right? A single container in the Docker can execute multiple processes as per the architecture of the application. So NGNX architecture is basically like master and worker architecture. So in the NGNX, you will always find one master or one worker or two worker, right? So we will execute the command to get the running processes inside the container docker container top then container ID. So let's execute this command. So I'll go to my terminal and I will find out my running containers. So these are two running containers, and suppose I want to know the process or running process of container 1, right? So I will execute the command docker container top then either container name or container ID. Press enter. So it will return you the process ID, right, and UID. So you can see over here the process 3271 is running, which is a NGNX master process, and another process 3311 is running, which is NGNX worker process, right? So with the help of the top command, you can find out the running processes of any container. So in this particular slide, we have discussed how we can provide a name to our container, how we can verify the logs of a container, and how we can get the running processes of my container. Let's move to the next one. And suppose you want to remove all unused containers. Then how can you remove the all unused containers? For this, you can execute the command docker container rm. Then if you want to remove the multiple containers, then you need to provide the space separated container IDs, or you can just provide a single container ID to remove that container, right? Let's see. So here is my terminal and I will execute the command docker container ls-a. It will list out all the running and stopped containers. And suppose I want to remove all the containers which has executed on this Docker engine. For this, I will execute the command docker container rm. Then I need to provide the container IDs space second container ID which you want to remove space third container ID which you want to remove, right? Press enter. So these three containers should be removed. The two was hello world and one was nginx. I will again execute the same command docker container ls-a, right? So you can see the last three containers is being removed from my list, right? Now suppose I want to remove a running container in the docker. So I will execute the command docker container rm and I will pass the running container ID like this. This is the running container, right, which is up. So I will pass this ID, press enter. So Docker will give you an error and error response from the daemon you cannot remove running containers. Stop the container before attempting removal or force remove, right? So this is for the security purpose. So by human mistake, sometimes you remove the running containers which may impact your running application. So Docker has provided this kind of security in their architecture so that you can't remove the running containers, right? So to remove the containers, first you need to stop them or you need to forcefully remove them, right? So we have already seen how we can stop the containers and how we can remove the containers. Now we will see, suppose if you want to remove the container forcefully, then how can you remove the container forcefully? For this, we need to execute the same command docker container rm, press -f and then the container ID. And this is the container ID which we want to remove. And this is this, right, which is the running container on port 80, right? I will press enter and this is being removed. I will execute the command docker container ls-a. See, the port 80 container is being removed, right? So this is the way how can you remove the multiple containers from your Docker. How can you remove a single container from your Docker? How can you remove the stopped containers, and how can you remove the running containers, right? So that's all for the day. In the coming lecture, we will learn some new things about the Docker. Thank you. We'll see you in the next lecture. Hello team, welcome to the Docker training, and in this particular lecture we are going to discuss about the Docker internal processing when we are executing the Docker run command. So let's start with. So we will see when we are executing the Docker container run command, what is internally is being processed with the Docker. So very first, Docker will look in the cache, image cache for the image which we want to execute, right? So suppose we are executing a command, Docker run nginx. So nginx is the image which we want to run with the help of the Docker. So after this command, Docker first look into the image cache for that particular image. If that image is not available in the local, then Docker go to the Docker remote repository. By default, it is hub.docker.com and download the latest version of the image. If you have provided the specific version of the image inside the command, then Docker will download that specific version of that particular image. If it's find the Docker image inside the image cache, then it will not go to the hub.docker.com and will not download the latest version or the specified version of that image, right? Now, after this, based on the image what it find, it will start a new container, right? So we have already seen all these things. Now, from the networking point of view, Docker gives a virtual IP on the private network inside the Docker engine on which that particular container will execute, right? So Docker internally will assign an IP to that particular container. So let's see. So here is my terminal and I'm inside my Docker machine. So I will execute a command docker container ls, right? So here is the container, here is the image which it is executing, the command which Docker is executing and created 40 minutes ago, and the ports. By default, you can see inside the container it is running on IP 0.0.0.0, right? So basically Docker creates its own virtual private network and define a specific IP to every container, right? We will discuss all these things inside the coming lectures when we learn about the Docker networking concepts. Now we will discuss about the ports. So in our previous commands, we have published some ports. The first port was denoted the host machine port and the second port was denoted the container ports. After that, Docker will open and port. Suppose we provided port 80 in the command, then it will open the port 80 on the host machine where the Docker engine is running and route all the traffic on the port 80 inside the containers, right? So there's two ports which Docker is using to run that particular nginx image. Because this is the architecture of the nginx, internally it will accept the traffic on port 80 and outside you can configure any port on which the traffic will route to the local container port 80. After that, it will start the container with the help of command cmd in the image docker file. So till now we have not discussed this particular stuff. When we learn about the docker file and docker image, then we will see how Docker will basically run the image with the help of the cmd inside the docker file, right? So that's all. This is all things which Docker is running or processing when we are executing the Docker nginx process and the Docker engine. Thank you. Thanks for your time. In the coming lecture, we'll see some more interesting stuff about the Docker. Hello team, welcome back. And today we will discuss about the containers versus VM. So in this particular lecture, we will discuss about the containers and we will discuss about the virtual machines. And we will see how containers are different from the virtual machines. So first, we will see some kind of similarities and some kind of differences between the containers and the virtual machines. So containers and virtual machines both have similar resource allocation and allocation benefits. In this way, we can compare the containers and virtual machines. They all run on a single host machine, right? On a single host machine, I can execute multiple containers, and this is true for the virtual machines as well. On a single host system, I can execute multiple virtual machines, right? And what all about the containers and virtual machines? So when I'm basically running the multiple virtual machines on a single host machine, then I'm allocating some specific chunk of resources to a specific VM, a specific virtual machine. This is true for the containers as well. When I'm running multiple containers on a single host machine, then basically I'm allocating specific resources to that particular container, right? In the previous lectures, we have executed the Nginx web server on port 80 and port 8081. So in that way, we have allocated two port, which is the resource of the hosting machine, the port 80 and port 8081 to different containers. So basically containers and virtual machines both have similar resource allocation and allocation benefits. But the containers and the virtual machine are functionally different. Why? Because the containers virtualize the operating system, but the virtual machines virtualize the hardware. To understand this particular statement, we need to go through the coming slide. And this is also the true that containers are more portable. So suppose you have set up 4 virtual machines on single host machine, right? Now you want to port these virtual machine with their own running processes and attributes. Then the virtual machines are as compared to the containers are hard to port, right? But the containers are more portable. You are running a single container like we was running the Nginx server on a container which is on the host machine. Suppose tomorrow I will change the host machine. So what I else need to do? I just need to install the Docker and execute that Nginx image. That's it. Nothing else I need to do to port my Nginx web server from one host machine to another host machine, which is not true with the virtual machines, right? When we are saying we will port the complete virtual machines, then we need to port the complete resource allocation. We need to port all the processes which is running on virtual machine A. So let's understand the second statement when we have mentioned that containers are different with the virtual machine, that containers virtualize the operating system, what virtual machines virtualize the hardware. So here is a specific diagram about the containers and about the virtual machines. The first diagram, the containers or containerized application are about the functionality of the container, and the second diagram, virtual machines are basically all about the virtual machines. So let's start. So there are two hosting machines, right? So host machine A is running the container and host machine B is running the virtual machines. So when we are saying we are running the host machine A, then you can say the infrastructure is there, then the operating system which is running on the host machine, and on that particular operating system we are running the Docker, right? So you can see the infrastructure layer is the lowest layer, and after that we have the second layer which is host operating system, right? So we have set up a Linux cloud machine, right, which is, so Linux is my host operating system, and over the Linux we have installed the Docker. So Docker is basically installed over the host operating system, right? So this statement is quite true because for the Mac we have separate Docker setup, for the Linux we have separate Docker setup, For the Windows, we have separate setup. For the AWS, we have separate setup. And in the same way, we have different kind of images which belongs to different kind of operating systems. So Docker always execute as the above layer on the operating system, right? And on that Docker we can run multiple containers. So you can see the app A, app B, app C, app D, app E, and app F. All are the containerized application which is running on the Docker. So what Docker is doing? Docker is basically virtualizing the host operating system, right? It's virtualizing the host operating system to the containers. But the statement is not true about the virtual machines, right? On the virtual machine, we will either use the hyperversion or we will use some virtual setups, right? And every virtual machine have their own operating system. They have their own specific allocated memory on the hardware, right? So the virtual machine A may have their own operating system, which could be Linux, could be Windows, could be Mac, and could be anything, right? The virtual machine 2 have their own operating system, and virtual machine 3 have their own operating system. And basically, when we are creating the virtual machines, so we are allocating a specific resource of that host machine to that particular virtual machine, right? So suppose we have a host machine which have the RAM 32 GB and which have the SDA about 500 GB, right? And if we are creating 4 virtual machine on that particular host machine, and we are allocating 2 GB RAM and 25 GB hard disk to every virtual machine. So in this way, we are basically defining, or we are basically virtualizing the hardware, right? The hardware configuration we are virtualizing, right? This is not the operating system based virtualization. We are dedicating, or we are allocating a specific hardware resource to a specific virtual machine. This is not true in the case of the Docker. Docker is just virtualizing the operating system. Rest, the memory allocation, the resource consumption will be allocated at runtime, right? So this is the difference between the containers and virtual machines. So containers are most optimized in the way of resource saving as compared to the virtual machines. Containers are not the virtual machines. Containers are just the processes, right? We have already discussed, we have seen, we have executed some containers. So containers are just the processes. There is no fixed memory allocation. There is no fixed resource allocation to the container. Containers are limited what resources they can access, right? So we have earlier seen that if we want to execute some container on some kind of specific port, so I'm allowed to do that. And the container which is running on that particular port is basically limited to access that port only, right? So containers are limited what the resource they can access. Containers exit when the process exits. So let's see the statement, right? So to discuss it further, I have opened my Docker machine in my terminal, right? So if I will execute the command docker container ls, then it will return me the running container ID. So only one container is running on my Docker, right? So you can see that particular container is running on my Docker machine. And we have stated that containers are just the processes, right? So suppose I want to see what process this particular container is running. So I will execute docker container top and then the container ID. Press enter. So you can see the two processes is basically running in this container. The first is nginx master process and second is nginx worker process. Now suppose I want to see how many processes are running on my host machine. For this, I will execute the command ps space AUX. Press enter and it will list out all the processes running on your host machine, right? So over here we can see there are two processes are running on this host machine. This is the nginx master, which is the process ID is 3271 and the nginx worker process ID is 3311. They are the same we have seen when we executed the docker top 2371 right? So basically you can see the container is just running the process on the host machine, right? If you want to just see the process which is running the nginx, then you can execute the command ps aux pipe, then grep, and then nginx. Press enter, and this will return you the process which is running the nginx. And you can see this is the master process, this is the worker process, and this is the command itself we have executed to search for the nginx process, right? Suppose I will stop my docker, right? So docker container ls, and I will execute the command docker stop and the container id, which is C4677. If you will provide 3 to 4 digit of the starting of your container ID, then Docker will automatically recognize it and close it, right? If I will execute the command docker container ls, so you can see nothing will be returned, right? It means the nginx container which was running on my machine has been stopped. Now if I will execute the command ps aux pipe grep nginx, so let's see what we will get. So we are not getting any process. So process is exited, right? So when we stop the container, the process exit itself. So basically the containers are just the running process, the executable instance of your image, right? This is not the case with the virtual machines. Virtual machines have their own operating system. Virtual machines have their own memory allocation. Virtual machines have their own RAM. Virtual machines have their own processes, right? In the case of the Docker and containers, the all processes are running on the host machine only. Okay, there is no separate operating system which is running the processes for your Docker, right? So that's all about the containers versus virtual machines. I hope the concept of the virtual machines and the containers are pretty much clear to everyone. If you still have the question, you can raise your question in question and answer forum, and I will happy to answer you. Thank you guys. Hello team, welcome to the Docker for DevOps training, and this lecture is all about the assignment. So today I'm providing you assignment to manage multiple containers in a Docker. So let's see what you need to do. So this is an assignment for you. Till now we have discussed a few things about the containers. We have discussed how we can run the containers, how we can stop the containers, how we can rename the containers, and many more things about the containers which is required as a basic knowledge. So today I'm posting this particular assignment for you so that you guys can do some homework and can do some hands-on on the Docker stuff. So very first, please list down these two links, docs.docker.com and dash dash help command. They will be very helpful when you are stuck in anything on a Docker. Docs.docker.com is a document for the Docker, which is an open source and community version, right? So anyone can put some information on that particular website and which is always up to date. So if you are stuck in some commands with the Docker, if you want some kind of knowledge about the Docker, then docs.docker.com is a very helpful resource to learn about the Docker and learn about the new things of new versions in a Docker. Dash dash help command will list down all the commands which is available with the Docker. So let's see. So right now I am on docs.docker.com, right? And over here I'm getting a lot of things, right? A complete documentation, a complete open source, and a lot of documentation is available on docs.docker.com. So it's your turn to explore this particular docs and learn what is required for you, right? So once I will go for the docs, so I will get a lot of information like how can I get the Docker, how can I start, and very helpful information over here, right? Over here we have the product manuals, right? We have Docker Cloud and the complete product manual, right? We have the references, we have the samples. So there is a lot of thing available on this particular website for a beginner and the Docker. I always sometime refer this website when I want to learn some new things about the Docker on which I don't have still hands-on, right? Now open the terminal, or let me found if I have already. Yes, so you can see I'm inside my Docker machine. If I will execute the command Docker version, then this will return me the Docker version installed on my machine. So Docker space dash dash help. This is a very helpful command, right? This will list down all the commands and manage commands which is available with the Docker. So if you want to learn a new command, if you want to try some new commands, then you can go through the help and learn about that command. And with every command, it has a very short description of this particular command. So you can Google about this command, you can try these commands. So basically docs.docker.com and Docker help are very helpful resource if you're learning the technology, Docker technology, right? Now let's see what we have an assignment for you guys. So we need to run multiple containers, right? So I want you would run nginx container, MySQL container, and Apache server on your Docker, right? We are not going to set up a fully functional application till we just want to run these three containers on your Docker machine, right? So before going to start with these containers, there are some guidelines which you need to follow in this particular assignment. First, I would like to you that you will run all the containers in the background. Also, provide a specific or unique name of all the containers which you are running. You should start the nginx on port 80 on host machine and port 80 on container. You should start Apache server on port 8080 on your host machine and on port 80 on your container. So if you have question, then we are running port 80 start for nginx as well, and we are running port 80 for Apache server as well. So here you should notice that the right hand port is basically the container port, and every container is an atomic, or you can say is an individual process. So these process can have the duplicate ports, right? Because the container A is not related to the container B. So nginx is running in a container A and Apache server is running in a container B. And you need to start MySQL on port 3306 on your host machine and 3306 on your container. So these are the things we need to carry when we are doing this particular assignment. There are a few more things which we need to carry when we are doing this particular assignments. So these are the things which you need to carry when you are doing this particular assignment, right? So basically, when you will start a MySQL container, it will ask you to provide, there's an option to provide the environment variable at the time of start of the container, right? So you need to use hyphen hyphen env command to pass the environment variable. And I want you would pass the environment variable MySQL underscore random underscore report root underscore password equals to yes. So it will generate a random password for you to log in into your MySQL containers, right? So basically, this is a very common way of the containers. Sometimes we need to pass the environment variables to the containers. So with the help of hyphen hyphen env or hyphen e command, you can pass the environment variables to your containers. And all the containers can have the different sets of environment variable for the testing environment, for the production environment, and for the deployment environment. Then you need to use Docker container log command on MySQL container to find out the random password after you started the MySQL container, right? And in last, clean all the containers after this assignment is done. So this is the assignment for you. you need to manage these multiple containers in this particular assignment. So in the next lecture, I will post the solution of this particular assignment, but I would highly recommend you that you should done it by yourself without any help from the next lecture. I will post the solution in the next lecture. Thank you guys. Thanks for your time. Hello team, welcome back. Welcome to the Docker for DevOps training. In the previous lecture, I have posted an assignment for you. Today, we will see the answer of this particular assignment. So I'm going to solve that assignment for you. So assignment was to manage multiple containers, right? This lecture is an answer to the previous lecture assignment. So if you have done your assignment by yourself with the help of the docs.docker.com, with the help of the Google, with the help of any other kind of resource, then that's pretty much good, right? If you still not tried the previous lecture assignment, then I would like to recommend, please try that assignment by yourself before watching this particular lecture, right? It may be possible that the command which we are going to execute in this particular lecture may be different from the commands which you have executed to complete your previous assignment. But the only things matter is the end result, right? So let's start with. So the assignment was to start the Nginx, MySQL and Apache server. And the some conditions was like all containers should run in the background, provide a name to all containers, start Nginx on port 8080. So let's start with the Nginx. So I am on my terminal and I have logged in my machine where my Docker is running. So if I will execute the command docker dash dash version, so it will return me the running version of the Docker, which is 18.06.1 CE, right? Now I will start my Nginx. So to start the Nginx, I will use the command docker container run, then execute in the background. For this, I will use hyphen hyphen detach. You can replace this command with single hyphen and d space. I need to publish the port hyphen hyphen publish port 80 colon 80. The first 80 port is open on the host machine and second 80 port will open on the container. If you want to short the publish command as well, then you can simply replace the publish with hyphen p, right? So we can replace the hyphen hyphen detach with the hyphen d and we can replace the hyphen hyphen publish with the hyphen p. These are the short abbreviation of these commands detach and publish. Now I need to provide the name. With the help of name command, I will provide some name to my Nginx server. So I will call it proxy server and the image name what I want to run. So I want to run Nginx. Just press enter. So you can see the container is started, right? If I will go to my browser and enter the command, the IP of the machine where the Docker is running. So my Docker is running on the cloud machine. So I will enter my cloud machine IP, then colon and the port we have provided. So it will open the Nginx web page. If you are running the Docker in your local machine, then you need to insert the URL like localhost colon port 80, right? Instead of the localhost, you can also mention your local machine IP. So it should open the Nginx web page like this on your machine. Now Let's start with the second one. After the Nginx, I need to start a new container which is Apache server on port 8080, right? So let's see. Before it starts the Apache server, we need to visit hub.docker.com to find out the name of image of the Apache server. I will log into my account. After the successful login on hub.docker.com, user will redirect to the dashboard. Right? Over here, you need to go to search and search for the Apache server. When you will search for the Apache server, you will get a lot of list of the search. Right? Over here, the first one is the official and name is HTTPD. This is the actual image of the Apache server. I will go to details by click on this link. And over here, the image name of the Apache server is HTTPD, right? And we are getting all the details related to this in the description. This is Apache HTTP server, right? And here are some more details of this particular image, right? So I will go to my terminal, and I know in past I never started the Apache server. So this is the first time when I'm going to start a Apache server. So it will look for the image in the image cache, and it will not find out the Apache server image in the image cache. So it will download the image, extract the image, and then execute the container, right? So I will execute the command docker container run -d to start the process in the background, -p to publish the port, and on host machine I want to publish Apache server on port 8080 and on container on port 80. -name to provide the container a specific name, and I will name it web server. After that, you need to provide the image name, and image name is HTTPD, right? Press enter. So it is downloading the image first, and after the complete download it will extract the image and execute that image for you. See, the Docker is started, right? If you will execute the command docker container ls, so you will see two containers are running. One is nginx and second is httpd, right? And names are similar which we have provided, the proxy server and the web server. Let's clear out the console and we will proceed with the third container. So the third container which we plan to start is MySQL container, and we should start it on port 3306 and inside the container as well port 3306. But we have some kind of prerequisite as well. And the prerequisite to start the MySQL container was we need to provide the -env environment variable to the MySQL container, right? And environment variable is MySQL underscore random underscore root underscore password equals to yes. After this, we need to search for the random password in the MySQL container logs. So let's start with. I am on my terminal and I will execute a command docker container run -d to start the container in the background, -p for the port 3306, and inside the container the port will be same 3306, right? I will name it MySQL DB, and with the help of -env I will pass the environment variable which was MySQL underscore random underscore root underscore password equals to yes. And then I need to provide MySQL image name. For this, I will go to hub.docker.com and in the search, I will type MySQL. Press enter. Uh-oh, there's a typo. It is MySQL. And here is the official image of the MySQL. I will click this and image name is MySQL itself. So I will go to my terminal and type MySQL, right? So MySQL also I'm executing this particular container first time on my Docker engine. So it will first download the MySQL, then extract the image and then execute this image. Let's hit enter. So it is basically downloading the MySQL. The size of this image is close to 500 MB. So just wait until the download will complete and it's done. Now we need to find out the password of my MySQL. For this, I need to check the log with the help of the log command. So Docker container logs, then the then the container name, and container name was MySQL DB. Hit enter and there is no command like this. Uh-oh, I forgot. See, there's a typo in the Docker. See, hit enter and it will print out the complete log of your MySQL. Now we need to find out the password which was generated automatically, right? So over here we are getting generated root password, right? You can copy this password for the future use, right? But we are not going to configure the complete environment right here, so there is no need. So we will leave it as it is. I just want to show you the way how we can do it, right? I will clear out my console. And in last, we need to clean all containers after the assignment is done, right? So we need to clean all the containers which we have executed. So we are on our terminal. We will execute the command docker containers ls. So okay, docker container ls. So see, three containers are basically running. The one is MySQL DB, the another one is web server, and the third one is proxy server. Let's clear the console and execute the command again. Now I need to stop these containers. So I will execute the command docker stop and then the container name, which is MySQL DB and web server and proxy. If you want to auto-complete the names, you can simply press the tab after some starting characters. Hit enter and it will stop all the containers. Again, hit the command docker container ls. So see, no container is running, right? If I will execute the command docker container ls space -a, so we can see the all containers are exited. Okay. If you want to remove these containers completely, you can execute the command docker container rm and then the containers name like MySQL DB, web server, and proxy server. And if you want, you can remove the web host 8081 as well. Hit enter. All the containers are being removed. Execute the command again docker container ls-a and you will not get anything. So we have cleaned up all the containers we have executed. So this is the complete assignment answer for you, right? So we have learned a lot of things in this particular assignment as well. In the coming section, we will learn some advanced things about the containers. Thank you. Thanks for your time. Hello team, welcome back. Welcome to the Docker for DevOps training. And in this particular lecture, we are going to discuss about the CLI monitoring of containers. So today we are starting the advanced section of the containers. Over we will learn about the CLI shell scripting of the containers. We will see the networking concepts of the containers, and then we will see how we can monitor and inspect the containers. So today we are going to learn how we can basically monitor the containers with the help of command line. So this lecture is all about to CLI monitoring and inspection of your running containers. So we will see what's going on inside my running containers, like how many resources are being consumed, what resources are being consumed, and what processes are running inside my running containers. So very first we will start a simple command, docker container top. So basically the docker container top will list you the processes which is running inside your containers. So let's see on a terminal that how docker container top will work for my container. So I'm on my terminal and I have logged in inside my Docker machine, which I have created over the cloud, right? If you are using your local, then you just need to go to your terminal. On my terminal, I will execute a command docker container ls. Press enter. So you can see nothing is being returned. It means no container is running on my machine, right? So first I will start a container on my machine. So very first I will start the nginx on my machine. For this I will execute the command docker container run -d for the detach mode dash name, and I will name it proxy web server. Then I will call nginx, my image name. Now you can see a container is running. Now if I will execute a command docker container ls, so I will get the running container. The image is nginx and name is proxy web server, which I just provided to my container. Now I'm going to execute a MySQL on my machine. Now let's execute a command docker ps, or you can execute a command docker container ls, and you will get nginx container is running and the name is proxy web server. I just provided to my nginx server. Now I will start another container of MySQL. So I will execute a command docker container -d -name, and I will call it MySQL db. Then -env to pass the environment variable, and environment variable name would be MySQL underscore random underscore root underscore password equals to true, and then I will pass my image name, which is MySQL. Hit enter, and it is saying this error with the -d. Okay, I forgot to mention the command run. So I will execute the command docker container run -d. Right? This is a silly mistake I did. Just press enter, and it will return you the container ID. I will clear out my console and execute the command docker container ls. See, I'm getting two containers running on my machine. One is MySQL and another is nginx, right? The container name of the MySQL is MySQL DB, and the container name of nginx is web proxy server or proxy web server. Now we will see how we use the docker container top. So we will execute the command docker container top. After this, either you can provide the container name or you can provide the container ID. First, let's start with the container ID. So suppose I am providing the container ID of the nginx, right? Hit enter and it will show the two processes are running. This is the process ID, right? And two processes are running in the nginx container. The first is nginx master process and another is nginx worker process. So with the help of the top command, we can verify how many processes are running inside my container, right? In the same way, if I would like to know the how many processes are running with my MySQL DB, then I will execute a command docker container top and I will replace the container ID or I will enter the container name, right? So it will show you the processes running inside your MySQL DB container. So only one process is running on your MySQL DB container and the process ID is 3952. So this is the way how can we verify that how many processes are running inside my running container. Let's see how we can inspect the container. So suppose we want to get the details or the configuration details of any running container, then how can we inspect or how can we get the configuration detail of running container? So for that, we will use the command docker container inspect, right? And if you want to run the command docker container stat, it will provide you the performance of the running containers. So let's start and get the details of both of these commands, docker container inspect and docker container stats, right? So we'll go to our terminal, clear out my terminal, and first I will execute a command docker container inspect. And suppose I want to know the inspect the running container, which is proxy web server. This is my nginx server, okay, and proxy web server is the name which I just provided to my nginx server. I will hit enter and it will show you the running details of your nginx server. See, a complete JSON is being printed over here, right? Once I executed a command, a complete JSON is being printed over here. See, this is a very long JSON which is being printed over here, and this JSON will provide you the complete information of your running container, right? So over here, the very first is the ID. This is the container ID, right? And then we are getting the created, the date and timestamp where that particular container is being created, and the path, and it is saying that it's nginx. The status is running, running is true, paused false, restarting false, and there is a lot of things like the process ID as well, and started at, finished and what image actually it is being used, and what are the path inside the containers where the files are being located, right? So you can get all the details over here, right? What is the name of the container, which is proxy web server, right? And here a lot of information like network is default. We will learn about it in the coming lectures. A very long details are being getting we are getting over here, right? So basically, when we want to debug a container, we need this command, right, to debug a container, right? So docker container inspect will provide you the configuration details of your running container, right? In the same way, if you want to get the configuration detail of MySQL, you can execute the command docker container inspect MySQL DB, which is my container name. If you want, you can provide the container ID as well. Just hit enter and it will show you docker container inspect. Okay, there is a typo error, right? And hit enter. See, a complete JSON is being printed for the MySQL as well, right? If we go through the complete JSON, then we will get the details. So this is the container ID, right? After that, it is getting the created date. After that, the path, right, which is this, the arguments, which is MySQL ID, And in the same way, you will get the name of your container, you will get the restart count, you will get the platform, somewhere you will get the networking mode, somewhere else you will get the port as well. So there is a lot of configuration information is basically available when you execute a command docker container inspect, and then you pass either the container name or the container id. So with the help of the inspect command, we can get the configuration details of the running container, right? This will not provide you the configuration details of the stopped or exited containers. Okay, this will only provide you the configuration details of the running container. So let's clear out the console. Now suppose you want to know, you want to check the status, the performance, or the memory, or you can say the resource consumptions of your container. Then you can execute a command docker container inspects. Oh, sorry, stats. Docker container stats. Hit enter, and it will give you the complete details or the resource consumption which is being used by your containers. So the only drawback with the status or the sorry with the stat commands is it will give you the container id instead of the container name. So with the help of the id, it is hard uh, basically which container is being running. But in the earlier version this was the problem, but in the newest or latest dockers we are also getting the name, right? With the version, I think with the version 16 dot the version which is prior to 16.0.8, there was the problem with the stats command, it will not show you the name of the containers. But with the latest versions of the docker, the issue is resolved, it will show you the container id as well as the container name, so that you can get which container is consuming uh, what what amount of resources, right? So you can see MySQL DB is consuming 0.45 or 47 CPU, and the memory uses is close to 400 MB, right? And limit is about 2 GB, right? It is using 18.36 memory, right? And here is the input output, here is the process id, and the second container which is nginx, it is using almost 0% cpu and 1.3 megabyte memory only, right? So with the help of the stats you can get the containers statistics data, right? So this is all about today. In the coming lectures we'll learn how we can basically enter inside the containers and execute some shell commands. So that's all for the day. Thank you guys, thanks for your time. Hello team, welcome back. In the previous lecture, we have discussed about the Docker CLI. Today we are going to discuss how we can SSH in a running container, right? So we will see what is the requirement of SSH the running containers and what else we can do after SSH the running containers. So let's start with. So today we are going to discuss how we can go inside the containers and modify something if it is required. And we will do it with the help of the SSH, with the help of the shell commands by opening a terminal inside the running containers. So what is the requirement of this? How we can do it and how we can exit out once we will complete. So basically when you will start and container, then there may be some kind of requirement. You need to change the port. You need to execute some commands inside your container. You need to modify that container as per your production or as per your test environment, right? But that's fine. If suppose we are going to modify something inside the containers, then we can also do it in the image. But for that you need to create the new image every time when you are debugging your container, when you are developing your container, right? So better option is you can easily modify the running containers and verify the results. So to modify the running containers, we need to use the container terminal. So we will open the container terminal, right? We will see how we can open a terminal inside the containers, and then we will see what kind of commands we can execute on the terminal, and we will see how we can exit out from that terminal. For this, first we need to start a container, or first we need to run a container in an interactive mode, and we will use the command docker container run. -i-t, or you can simply execute docker container run -it. So we are going to discuss about this command in a very detailed manner. Right now you just need to remember we will use docker container run -it to start a container in an interactive mode. When I'm saying in interactive mode, it means user can interact with the running containers. So let's go to the terminal and start a container with docker container run command and open the terminal inside it. So I'm on my terminal, and if I will execute the command docker container ls, then I will see only one container called nginx is running. So I'm going to use my command to start a container in interactive mode. So I'm going to start a container with the help of docker container run in interactive mode. But before this, I will see a help of docker container run. For this, we will execute docker container run dash dash help. Hit enter, and over here you will see few options. So first we will learn about the syntax of the docker container run command. So here is docker container run, this is the command. Then we need to provide the options, then the image name, and then we can provide the commands and arguments which we want to supply to our running container. Now we will discuss about the -i and -t. So let's scroll a bit, and here is the -i. This is saying interactive, keep stdin open if not attached. So it will keep your session open with a terminal, right? And which command will be used to open the terminal? The -t. See, -t is used for -tty. This will allocate a pseudo terminal to your session, right? So now we will open up, or we will start a nginx container in interactive mode. For this, I will execute a command docker container run. Then I need to provide the options. So I will provide -it to open the interactive terminal. Then I will provide the name of my container. I will name it web proxy. Then the image name. And after this, I need to supply the commands. So suppose I want to open a bash in my container. The container is nginx. So I will supply bash over here. Hit enter. So you can see the ID and the user is being changed. Earlier I was on this particular machine, right? Now it is returning you the current container ID. You are right now inside your container. If you will execute a command ls-a, then you can see these are the files which is present inside your container. This is the Docker environment, bin, boot, dev, etc, lib, lib64, media, mnt, op. There are a lot of files which is present inside your containers. Right now you are running inside your container. If I will execute a command ls-lrt, then you can see these are the files, or these are the directories which is present inside your container, right? So right now I'm on a terminal of my container. I'm not a terminal of my local machine. I'm running a bash of my container, and the container name is nginx. If you want to exit from this terminal, then you can simply execute a command exit. Hit enter, and you will exit out. Now you return back to your local machine. See, I return back to my local machine. So this is the way how you can open the terminal of your container. Now I will execute a command docker container ls, and you can see only one container is running, right? And the container name is quiz call goodall, right? This is not the container we started. We started the web proxy. If I will execute a command docker container ls-a, now you can see with the help of command docker container ls-a, I am getting all the containers which are being executed on this machine. So this is the container web proxy. We provided this particular name to my container, and this is exited as soon as we entered the command exit. So using this way, you can just start your container and modify something inside your container, right? But as soon as you will press the exit command, it will stop your container. You can also see there's a difference inside the commands. This is the default command which will be execute once the nginx start by default without any command. But we started our nginx with the command bash, so we are getting bash over here, right? So this is the way how you can modify the containers, how you can go inside the running container. So today we have discussed how we can start a container and modify it. In the coming lecture we will see how we can
modify already running containers. So thank you guys. Hello team, welcome back. In the previous lecture, we have discussed about the Docker run command. We have seen how we can start a container and open the terminal in that container. Today we are going to start with some other commands and we will see how we can execute the commands in already running container. So let's start with. So today we are going to discuss how we can get inside the running containers and execute few commands. So we will go inside the running containers and execute any desired command. So this is a very helpful extension in the Docker which we will use to debug, analyze any kind of issue, and we can change anything inside the running container. For this, we need to use the docker exec command and the format would be like this. So to change anything or to go inside the running containers, you can use a command docker container exec-it. Here exec is a stand for execution and we have already discussed about the -i and -t. So it will open the terminal of a running container or it will directly insert a command inside the running container. So we will see how we can open the terminal of a running container or how we can directly insert a commands inside the running container. The docker exec commands runs a new command inside the running containers. So we are going to discuss this particular stuff with example. So here is the full-fledged example. First we will discuss about the steps, then we will execute the same scenario on Docker. So let's discuss an example and execute an example to understand the docker exec and docker run command or to identify the difference between the docker exec and docker run command. So in this particular example, we are going to follow these steps. So first we will start an nginx, then we will run commands to create directory inside the running container, right? After this, we will verify the new directory which we have created inside my running nginx container. After this, we will download a new Linux Alpine distro on my Docker. So Alpine is a very small Linux distro which is available on the Docker central repository. After this, we will use some curl command to view the Facebook homepage DOM on Alpine. Right? So these are the things we are going to execute on a Docker. So first, I will go to my terminal and I will verify is there any nginx container running or not. For this, I will execute a command docker container ps. So you can see an nginx container id ffd6f is running on my Docker machine, right? So this is the running container. Now, as per our task, as per our scenario, we want to insert something in this particular running container. Very first, we need to verify the directories which are available inside the nginx. For this, I will start a new container of nginx and I will verify the directories which are present inside the nginx image. For this, I will execute a command docker container run -it -name nginx web, then support, then provide my nginx image name and bash. Hit enter. So right now I am in my image of my nginx. If I will execute a command ls-a, then I can see these are the directories which are present inside my nginx image. If I will go to temp and again execute a command ls, so inside the ls I don't have anything. Inside the ls I don't have any directory. You can see there is only few hidden directories but no public directories available inside the temp of my nginx image. I will exit out this container. Now I will see how we can execute the docker exec command. For this, I will execute a command docker container exec. I will execute the docker container exec in interactive mode. We have discussed about it. Then I need to provide either name or ID of my running container. And this is the ID of my running container. So I will provide the ID of my running container. Then to create a directory inside a running container, I can use command touch, provide the path. So path is temp. And suppose inside the temp, I want to create a directory name Anshul. Hit enter and command is completed. So you can see with the help of docker container run,
we started a new container of the nginx, but with the help of docker container exec, we have executed some command inside the running container. This is the id of my running container, right? Now if I will go to my running container with the same command docker container exec, I can go to my running container, but instead of touch and file name, I can enter bash. So it will open up the bash of my running container, right? Hit enter. So you are inside your running container. You can see user is root and this is your running container ID. Over here, I will go to temp, right? And inside the temp, if I will again execute ls, you can see a new directory unsure is present over here. So with this command, with the exec command, we have created a directory inside the running container, right? But this thing is not possible with the run command, right? Run command is just used to start something, execute something, and then exit out. Now we have seen how we can go to inside the running containers, create something and verify something. Now we are going to start a Ubuntu container with the help of Docker and command, and we will execute some commands inside my running container, right? For this, I will enter command Docker container run -it, then the image name, right? Then bash. Hit enter. So what it will do, it will download the Ubuntu distro on your machine, right? And it started a container with this particular ID, and right now you are already inside the running container, right? If you will execute a command ls-a, then you can see you are inside the Docker environment, bin, boot, dev. These directories are present inside this particular Ubuntu distro, right? If you want to execute a command curl www.facebook.com, hit enter, and it will say bash curl command not found. This why we are getting this particular error. So we are getting this particular error because the Ubuntu image which is available on the Docker Central repository is small than the ISO image of Linux or Ubuntu. The ISO image of Linux and Ubuntu have a lot of packages, a lot of functionality inbuilt in it, right? But the image which is available on the Docker Central repository is very basic image. So first I need to install everything what I want to use. So first I will update my apt-get packages. I will execute a command apt-get update and it will update your package system. It's done. Now I will install the curl. I will execute command apt-get install curl and it will install the curl utility on your Ubuntu container. Now I will clear out my console. Now if I will execute curl https www.facebook.com, then you can see a complete HTML web page of Facebook is being downloaded. You can see the HTML is NL, ID is Facebook, and here is the Node.js class, and everything which is reside inside the Facebook web page is being present on your console, right? If you will replace the Facebook with some other website like Google, then you can see you will get the Google web page, right? See, you executed the same command for the Google, now you are getting the Google web page, right? This is the Google web page HTML structure. So this is the way how you can go inside the containers, how you can basically start a new container and open the terminal in that container, and how you can execute some commands inside the containers, right? Right now I'm inside my container. You can see over here I'm not getting my local directory name. I'm inside my Ubuntu container, and inside my Ubuntu container I'm executing these commands, the Facebook and Google curl commands, right? So you can execute anything inside the container, either it's a running container or you are starting a new container, right? If you will exit and you will insert a command docker container ls-a, so you can see the Ubuntu container, right? It is being exited just 12 seconds ago. Hello team, welcome back. And today we are going to discuss about the networking in Docker. So let's start with. So we are going to discuss about the networking concepts in the Docker. We will see how the containers will communicate to each other, what is the requirement that container can have to communicate with the other container. So Docker container and the services can be connected with each other. So for example, we can see when we are running two containers on a same Docker machine within the same network, like we are running PHP container and we are running MySQL container, and for my web application, the PHP container must communicate with MySQL container. So in that case, they both should be connected over the same network. They both should be able to communicate with each other over some ports, right? So Docker container and services can be connected to each other. Container and services don't need to be aware where they are deployed. It means we are using two Docker machines, one is hosted on Windows and another is hosted on Linux, then the containers don't need to bother where the hosting machine is working. They just need to know about the networking layer or the bridge, what they need to use. And it means the containers and the Docker services don't need to be aware where the Docker is basically hosted. It may be possible one of your Docker is hosted on a Windows machine and another is hosted on a Linux machine, and you are executing two containers, one on Windows and another on the Linux. In that case, the both of the containers must know about the bridge, about the network, what they need to use. They don't need to bother about the hosted system. Containers and services can communicate whether your Docker host run on Linux, Windows, or mix of two. So we have already discussed about it. The only thing which is required to establish a connection or establish a communication between two containers is a network bridge. And all the communication which is possible between the Docker containers is possible because of the default drivers inside the Docker, right? So we will discuss what is the default driver inside the Docker and what is the application of this driver. In a Docker, each container connects to a virtual private network, and that network is called bridge, right? So in Docker, bridge is a default network driver of the Docker. In a real time or in terms of networking, a bridge network is a link layer device which forward traffic between network segments. A bridge can be hardware device or a software device running on a host machine, right? But in terms of Docker, a bridge network uses software bridge which allows containers to connect to same bridge network to communicate while providing isolation from the containers which are not connected to that bridge network. The Docker bridge driver automatically install rule on the host machine so that containers on different bridge networks cannot communicate directly to each other. So basically, with the help of the bridge network, we are getting a communication medium, plus we are also getting some kind of network security. So the containers which are on the same bridge can communicate to each other, but in the same way, bridge will also take care that the container which are on the other bridge can't communicate to the containers which are running on my bridge. All containers on a same bridge can communicate to each other without port, right? If we are running two or three or n containers on a same bridge, then we don't need to mention about the port in the command. The containers can be communicated to each other without any port. Now we will talk about the best practices to create the networks, right? So suppose we have a two application A and application B. Application A is a combination of PHP and MySQL. So we can create a separate network bridge. We can call it SQL PHP and WT. This is a custom name, you can use anything, right? All we need to concern is about a separate network bridge. So for this application A, we can create a separate network bridge, and only MySQL and PHP containers will be allowed on that particular bridge to communicate each other. For my application B, which is running on Mongo and PHP, then I can create another network layer or another network bridge, call it Mongo NWT, and I will make sure that that PHP container which is running on that particular network can communicate to Mongo only. So over here we are providing the security to my containers. Over here we are defining the rules, we are defining the policies, how the containers will communicate to each other and which container will communicate to which container. Docker networks, or you can say the network in Docker, is easily plugged in the containers. We can say user is allowed to create multiple virtual private network bridges in a Docker. In the same way, you can create multiple rules for a single network. So network is basically very extensive and very portable service in a Docker, right? You can use multiple virtual private network, you can use multiple bridges, you can create multiple networks, and for a single network you can create multiple rules. It may possible that you can attach multiple containers to a single network. Also, it may also possible you can attach a single container to more than one network. Or you don't need to attach any network to the container. In that case, it will auto assign the bridge network to that particular container. I hope now you get some idea how the networks are working inside the Docker and how the containers are communicating to each other. In the future lectures, we will dive deep inside the networking concepts. We will learn about the private network, public network, virtual networks. We will create our own networks. We will create the containers which will use the same host machine and multiple networks, and we will create a complete swarm cluster, right? Hello team, welcome back. And today we are going to discuss about the networks in container. So we'll see how container will use the networks, how container will talk to bridge and how bridge talk to the host machine, right? So let's start with. So very first, we will start a container to allow traffic from a port on a host machine, right? For this, we will execute a command docker container run -p, then we will define the host port and the docker port. After this, we will start it in a detached mode, right? Then we will find out the traffic and protocol. So we will find out which port is allowed to send a traffic on a container, which port is allowed to receive the traffic inside the container, and which protocol we will use. After this, we will find out the container IP with the help of command docker inspect. So to execute all the commands, let's go to the terminal. So here is the command docker container run -p port 8080 colon 80 -d, then the image name. So first port 8080 is a port which will open on a host machine, right? And the second port 80 is a port which will open on the container. So we will start this container. So you can see container is being started and ID is F45175, right? Now I need to find out the IP of my local machine, right? For this, I will execute command if config eth0, hit enter, and here is the IP of my machine, which is 178.128.245.221. I copy this IP, go to my browser, paste it over here, put colon and paste port 8080. Why I am putting port 8080? Because I opened port 8080 on my host machine. So let's see what we will have. So we can see on port 8080 we are able to open the Nginx web page, right? So this is the same Nginx we are running inside our container in a terminal right here, right? Now we need to find out which port is receiving the traffic inside the container and which port is sending the traffic to a container. For this, first I need the container ID and I will execute a command docker container ps. And you can see two containers are running, right? And the latest container which is started 2 minutes before is this. So this is the IP of that particular container. So right now to find out the traffic and the port on a container, I need to execute a command docker port. Then I need to define the container ID. So I copy this ID and paste it over here. Hit enter and you can see inside the container it is running on port 80 and accepting the traffic over the TCP protocol. And it is accepting the traffic from anywhere because the port is 0.0.0.0 and port 8080. So over the internet you can call it on port 8080 over the TCP network layer, right? Now, suppose you want to verify the IP of your container. For this, you need to execute a command docker container inspect and paste your container ID, right? So we are going to execute a command docker container inspect and the container ID, hit enter, and you will get a very lengthy JSON. Over here, we need to find out the node called network setting. So here is the network setting node, right? And over here, you will get the IP address of your machine. And here is the IP address, right? Which is 172.170.3, which is different from my local machine IP, right? If you want to format out this command, you can execute a command docker container inspect dash dash help, right? So over here we have -f option to format. So I will display the inspect JSON in a specific format, right? For this I need to find out my container ID. So, so here is my container ID. Now I will execute a command docker container inspect -f, then put colon, then put braces like this. Over here I need to put dot to access my JSON object, and over here I will put network settings dot IP address. After this I need to provide the ID of my container. Hit enter and you can see it will return you the port of your Docker container. So this is the port on which my Docker container is running. So Docker container is running on a port 172.17.0.3 and ipconfig eth0. This is the port of my local machine. So you can see the port of my local machine and port on the container is different. So it visible that container is not using my local network. Container have its own virtual private network which we have discussed in the previous lecture, and the default network is called bridge, right? Now we will understand it with the help of a slide that how the all things are working over here. Now we are going to understand the networking, how the networking is working inside the Docker. So here is the outer world. This is the internet, and from the outer world or the internet, you are receiving traffic on your machine. So this pillar is your machine. But inside your machine, you have a local firewall which is accepting or rejecting the traffics from the internet, right? Because if that firewall is not working, then definitely your machine can be accessible from anywhere. So in your machine you have some kind of rules, some kind of regulations that who can access your network, who can access your machine and who can't access your machine, right? So here is the outer world, right? And here is the machine, and inside the machine a firewall is working. Now here we have a bridge, right? On a machine Docker is running and Docker is using its own network which is called bridge. This bridge is basically communicating to your local host machine, right? Because Docker is running on your machine and they are containers like container 1 and container 2. They containers are talking to each other with the help of a bridge. So you can see right now container 1 and container 2 which is running inside the Docker, they are not communicating with the help of your host machine. They have their own virtual private network called bridge, and they are communicating to each other with the help of this particular virtual private network which we are calling bridge, right? Now suppose in a last lecture we have seen that my machine, my local host machine was communicating to my container on port 8080. The communication between the two containers are without any port. So if you are using the same virtual private network within the two containers, then to communicate with each other they don't need any port, and the IP of each container should be different. But if your container is talking to your local machine or the host machine, then they need some ports. A port which will open up at your local host machine, which will accept or send the traffic, and a port which will open up inside the container. So inside my local host machine, I am sending the traffic on port 8080, which will be received inside my container 2 or the Nginx container on port 80. And that communication is with the help of the bridge. So first container is connected to the bridge, bridge is connected to your local host machine. In the same way, when you are hitting this particular request, when you are hitting this particular request on your port, on your local port, you are hitting port 8080. So first it is connecting to your Docker virtual private network, and then virtual private network sending the traffic to your container on port 80, so that you are getting this particular web page. So I hope right now the concept of networking and how the containers are communicating to your host machine and how the containers are communicating to each other is pretty much clear to you, right? Now suppose we can create n number of virtual private networks inside a Docker. So we will create another
virtual private network and call it MySQL PHP network, right? And right now I have two another containers, MySQL container and PHP container. So they container can communicate to each other with the help of this particular private network, right? With the help of this particular MySQL private network. But if MySQL needs to communicate with my local host on any port, then they need to communicate over a specific port, right? So port required to open the connection between the host and the container. But if two containers are running inside the same network, inside the same virtual private network, then they don't need any kind of port to communicate with each other, right? So this is the concept of networking inside the Docker and your local host machine. Now we can see we are able to access the nginx on port 8080. If we will refresh this page, then we will get the same thing. Now I will go to my terminal and stop my container, right? So for this I will execute command docker container stop and my container ID. So I will copy this ID and paste it over here, right? So this container is stopped. Now if I will again go to my browser and refresh my web page, then you can see you are getting the error. So you are not able to connect it or communicate it to the containers because container is being stopped. If I again start that container with the help of command docker container start and then the container ID, right? It's been started. Again go to my browser and refresh this web page. So it will again display me the web page, right? So it is being able to communicate with the nginx. So this is how the networking, how the containers and how the virtual private network inside the container are working and communicating to the host machine and communicating to another containers. I hope you like the video. Thank you guys. Thanks for your time. Hello team, welcome back. And today we are going to discuss about the Docker network command line management. So we will see how we can manage our Docker networks from a command line or from CLI. So first we will see how we can list out all the networks which are running on my host machine. So with the command docker network ls, you can list out all the networks which are running on your host machine. So basically the command docker network ls will list all the networks the engine daemon knows about. So on your host machine engine knows about all the networks will be listed out with the command docker network ls. And docker network ls command will come with some kind of optional configuration as well. So if you want to prefer something, suppose you want to filter out the networks which all are the bridge networks, then you can use the docker network filter. And for that you can execute a command docker network -f for the filter, and it will define the key value pair. So key is the driver, right, and the value is the bridge. Also you can filter out the networks on the base of the name, on the base of the scope, on the base of the ID, right? So you just need to provide the key value pair, right? So docker network filter command will work on a key value pair. You need to define the key and value about which you want to apply the filter. To find all the networks IDs and drivers, you can use the command like docker network ls format, and then you can provide a simple JSON format, right? It is again JSON object and JSON value, right? So let's see how we can perform these commands on a terminal and what will be the output of these commands. So I am on my terminal. First, I want to list out all the networks which are running on my host machine. For this, I will execute command docker network ls. Hit enter, and you can see three networks are running on my host machine. One is a bridge network, another is a host, and third one is a null, right? So this is the command from which we can list out all the networks which are running on a machine. Over here we are getting the network ID, we are getting the network name, the driver, and the scope. So you can see the scope of all the networks are local. These three are the networks which will be initiated and created by the Docker engine itself. It all depends on the version of Docker which you are using. If you are using the latest version, then you will get most probably three networks. Maybe in future you will get most probably four, five, or two, or one, right? So it all depends on the version of the Docker you are using, that how many network will be listed out by default. Now suppose you want to get some help on Docker network command. So you can execute command docker network dash dash help, hit enter, and it will show you the command is docker network, right? And over here the commands you can provide, and commands are connect, create, disconnect, inspect, ls, prune, and rm. So we will see all these commands. First we'll talk about the ls, right? Now suppose you want to list out or you want to filter out all the networks which have the driver as a host or as a bridge or as a null. For this you can execute a command docker network ls. Then you need to use option command -f, which is for the filter, and you need to define the key and value. So key is driver and value is bridge. So by this command I'm expecting I will get a list of all the networks on my host machine which have the driver bridge. Hit enter and you can see it's working. The network ID 7374, the name is bridge, have the ID bridge. So it will list out or filter out all the networks which have the driver bridge, right? Now suppose you want to find out all the network IDs and drivers which is running on your Docker host machine. For this you can execute a command docker network ls, then use dash dash format to format the output, and this will return you the data in format of JSON. So we need to filter out the values. So for that I will provide the argument as a double quote, then open the curly braces, close these curly braces, press colon space, open double curly braces, close these curly braces, and over here first I need to read the object of ID, right? And over here in a value I need to read the object of driver, right? Hit enter and you can see it is printing all the network IDs with their drivers, right? So you can see, so this is the way how you can work with docker network ls command, right? So we have seen the functional use of all these commands. Now we will discuss about the next command, docker inspect. So we learn about the docker network inspect. So docker network inspect will return the information about one or more network. By default, this command will render all the results in a JSON object, right? So let's start and inspect any element, right? So suppose I will go to my terminal and execute a command docker network inspect, and I need to provide the ID of the network which I want to inspect. So I'm going to inspect this bridge network. So I copy this and paste the ID over here, hit enter, and you can see it will return you a complete JSON format, right? And it is saying the name is bridge, ID is this, created at this particular time, the driver which is using is a bridge, right? And we are getting another information as well, like the containers which are using this particular driver. So right now, two containers are using this particular driver network. The first Docker container which is using this network is inspiring Shockley, right? And the second is quiz call Goodall, right? So these two containers are using this particular driver, right? And you can see it is also providing the subnet IPs. So one is using this particular driver on 172.170.3 subnet, and another one is using on subnet 02, right? So that's all about the container network list and container network inspect, right? In the coming lecture we will discuss few other commands of Docker container network, right? So thank you guys, thanks for your time. Hello team, welcome back, and we will continue with our previous lecture, Docker Network Command Line Management. Today we will discuss how we can create a new network and how we will connect a container with the network, right? So to create a new network on a host machine, you can use the command docker network create and then provide your network name, right? Once you will execute the above command, basically it will create a default bridge network, right? So by default bridge network is assigned to all the containers, and when you are not defining that which kind of network or the driver you want to use, then by default any network which you will create on a docker host machine, it will be created and assigned to the driver which is called bridge, right?
and we have discussed about the bridge in the previous lectures. Now suppose we want to create a bridge network, then it will be created by default command docker network create -d for the detach mode, then bridge, which is the driver, then your network name, right? So let's see how we can create a network. So right now I am on my terminal and I will execute a command docker network ls. So we can see the three networks are running on my machine. Now I will create a new network and I will execute the command docker network create and I name it my network. You can see ID is being returned. I will again execute the command docker network ls, hit enter. Now you can see a new network is being added in your network list. And by default, the network driver is bridge. So when we are not defining any specific driver or any third party driver to my network, then Docker create a network of bridge type. Right? Now suppose if you want to inspect your newly created network, then you can execute a command docker network inspect and either your network name or ID. So I will going to provide my network. This was my network name. Hit enter. So you can see this is the network. This is the ID, the creation time, the driver type, and other details. Right. So this is the detail of network which you just created. Right. Now we will see how we can connect a container with a network. So we can connect a container with a network with the help of command docker network connect. Then we need to define the network name and my container name. So Docker network will basically work in a same concept on which our local networks work. Like you can plug new device, you can unplug the device, you can switch the network on the device. We can create a new network and assign that network to already running container. A single container can belongs to two network. A single network can belongs to multiple containers, right? So we can connect any container by name or by ID with particular network. After connection, the container can communicate with other containers in the same network. So we have already discussed about it. The two containers or n container which belongs to same network, they can communicate to each other without any port, right? So we have already discussed about these concepts in a networking, right? Now we will see how we can connect a new container on a new network. Now I am on my terminal and first I want to list out all the containers running on my host. For this, I will execute a command docker container ls. And we can see two containers are running on my host machine. Now we will see the networks are running on my host machine by command docker network ls. And I have four networks are running on my host machine. And the third one, my network, is a default network which I just created before. Right? So what I will do, I will create a new nginx container and attach this particular network, my network, to that particular container. And then again inspect my network, right? So that we can see the container is attached to my network or not. For this, I will execute command docker container run, then -d for the detach mode. I need to define the name of my application and I will define it my nginx, then dash network. I need to define my network name and my network name is my network. Then the image name which I want to start, right? Hit enter and container is being started. I again execute a command docker container ls and the you can see a new container named my nginx is running, right? Now I will inspect my network again. Docker network inspect, then your network name, hit enter and see a new container is being added, right? The container ID is this and container name is my nginx. So a new container is started and joined my network which I just created, right? If I will go and inspect my nginx container, then let's see what will happen. So clear out the console and execute docker container inspect my underscore nginx. Hit enter. So you can see in the networks, it is using my network, right? And this is the network ID, this is the endpoint, and this is the gateway. Now we will connect a already running container to my existing network. For this, first clear out your console. Find out the number of containers running over here, Docker container ls. So we can see two other containers, Inspiring, Shockley, and quiz call Goodall is running on my host machine. And obviously I didn't define any network to these containers, so they may be working on default container. And obviously I didn't define any specific network to these containers, so that they are already working on a default network, which is bridge. So I will inspect any of them by Docker container inspect. Now I will define the name, hit enter. So you can see the network is bridge, right? So this is working on a bridge network. I will clear out my console. Now I will use the connect command to connect already running container on a new network, right? For this I will execute command docker network connect. Then I need to define my network name, and my network is my network, and my container name, which is quiz call Godal. So here I'm defining docker network connect, then I'm defining my network first, then my container as a second argument. Hit enter. It's done. Now I will again inspect my network. Docker network inspect my network, hit enter, and you can see two containers are joined my network, right? The first one is my nginx, which I started on a new network, and second is quiz call Goodall, right? So this is the way how you can connect a container to any network, right? Clear out your console. Now if I will inspect that particular container, let's see what we will have. So docker container inspect, then you need to define your container name or id, hit enter. And over here you can see this container is basically connected with two networks. The first network is bridge. The first network is bridge, which is listed over here, and second network is my network, which are just attached to this container. Now suppose you want to disconnect your container with the default network, right? For this you need to execute a command docker network disconnect. Then you need to define the network name. So I want to disconnect my container with the default network. The name is bridge. And you need to define your container name. My container name is quiz call Goodall, right? Hit enter and it's done. Now I will again go to my container inspect. Then I will see my container should be disconnected with the default network. So docker inspect. So docker container inspect. Then you need to define your container name. Hit enter. And you can see inside the network you are getting only one network which is attached to this particular container, right? Now you can also try and you can see if you generally disconnect all the networks from any container, right? So suppose I want to disconnect my container with all the networks. For this I will clear out my console and I will again execute the same command, but over here I will change my network name. So I want to disconnect my quiz call with my network, which is my network. Hit enter and it's done. Now if I will again inspect my container, then let's see what we will have. So you can see inside the network setting, you are not getting anything. This container quiz call all is not connected with any network, right? This is not connected with any network. Right now, if you want to communicate with this particular container, then you would not be able to communicate with this particular container, right? So using the same way, we can use the network in our local machine, in our local hosting systems. You can use the network in the same way inside the Docker and containers, right? So that's all about the Docker container CLI. In the new lecture, we will discuss about the DNS. So thank you guys. Thanks for your time. Hello team, welcome back. And today we are going to discuss about Docker network DNS. So we will see how Docker container communicate to each other. So before we move further, let's try to understand what is DNS. So DNS stands for domain name system, right? DNS is something which will be translated into IPs, right? So DNS is how domain name are translated into IP addresses. So suppose for example, you are running a website like you are running facebook.com. Then facebook.com is a domain name which finally land on some kind of server, and that server has the IP. So DNS is allow you to translate your request into the IPs. DNS which allowed you to access your servers with the help of web browser with a unique name, right? So every server has the IP, but the same server has the host name, and that host name which we can access with the help of the browser, with the help of any tools like a WinSCP, like Putty, through which you can connect to that server is called DNS, right? DNS makes it possible for us to use remember domain name in place of complex IP addresses. So for example, you are running a website and your website domain name is something like testdomain.com and you want to publish your website over the internet. Then to remember the complex number like 189.179.11.21, it is easy to remember the name, right? It is easy to remember the name instead of a series of number. So DNS make it possible for us easy to remember the domain names instead of the IP addresses, because it's not possible that you can remember the IP address of each site, but it may be possible you may recognize these site or you may remember about these site with the help of specific domain names, right? Now let's discuss how container communicate to each other with the help of DNS. So containers use DNS to communicate. And what is the DNS for the containers? So the container name is used as a DNS, right? Containers don't use IP address to communicate. So we will try to understand why container use their name as a DNS, why they don't use the IP address to communicate. For this, first go to the terminal. So I am here on my terminal, right? So we need to find out how many containers are running over here. For this, I will execute a command docker container ls. Hit enter. And you can see only one container name is inspiring Shockley is running on my machine, right? Now we need to find out how many networks are running on my machine. So I will execute a command docker network ls. So we can see the four networks are running on my machine, and this is the third network is the network which I just created in the previous lecture. So I am going to inspect this particular network. For this, I will execute a command docker network inspect and then the network name. Hit enter and you can see no container is basically attached to this particular network, right? This network is not attached with any container. Now what we will do, we will create two new containers, right? So first clear out the console. Now let's start two new containers. So first we will start our first container with the help of command docker container run -d for the detach mode. Then I need to define the name of my container and I define it my nginx 1. I define the network and in the network I define my network, right, which I just created before. Now I need to define the image name. So I'm going to define the image name nginx colon alpine. So over here you can see I'm going to download the new image of nginx which is alpine. Why I am doing this, I will explain it later. Hit enter. So first it will download the image, then start the container. Docker container ls. The two new containers are running, right? My nginx 1. Now in the same way I need to start another container my nginx 2. So I will execute the same command, just replace the name of my container with my nginx2, and I will create nginx alpine container. Hit enter. So another container is being started. Run the command docker container ls, hit enter, and you can see three containers are running and two containers are nginx alpine image and one container is nginx latest image. Right now we will again go and inspect our network with the help of command docker network inspect. Then network name, and you can see two containers are running over here. First container name is my nginx1, second container name is my nginx2. Over here I have the IP 172.18.0.2, 172.18.0.3. Right? Let's clear out the console and I will try to ping my second container from my first container. Right? For this I will execute a command docker container exec -it for the interactive mode. Right? Define your first container name. So I'm going to define my nginx1. So what I'm trying to do, I'm trying to execute a command on my first container. And what is the command? Ping my second container. Right? So I'm going to execute a command on a first container. And what is the command? Ping my second container. Just hit enter. And you can see I'm successfully able to ping my second container and IP is being resolved 172.18.03. So you can see the containers can communicate to each other with the help of the names. So I tried to execute a command on my first container and I execute a command of ping on my second container by the container name and it's successfully done. Right? So containers are using their name as a DNS to communicate with each other. If I will do the same thing in opposite manner, suppose I want to ping my container 1 from my container 2, hit enter, then see it is able to resolve all the calls. Right? Now I am able to communicate with my container 1 from my container 2 with the help of my container name. This proves that container use their name as a DNS to communicate. Right? Now question comes, why we are not using IPs? Why container is not using IPs? Because IPs are a static in container. Right? IPs is a static value in a container. When you basically stop this container and again start a new container, then it may possible the same IP will address to a new container. In that case your call may be redirected to wrong container. So we can see this example as well. For this, let's start any of the container. So I will execute a command docker container stop and I will stop my first container, my nginx1. And we can see my nginx1 IP is 172.18.02. Right? I stop it and I again start a new container, my nginx3 on a same network. For this, I will execute the same command container run -d name my nginx3, network would be the same my network and nginx alpine. Hit enter. Now it may be possible or may not be possible that the same container can obtain the same IP. It may be possible that this container may obtain the IP4, but we are just playing with an hit and try. I will inspect my network again. So docker network inspect my network. Hit enter. And that's true. You can see the new container which I just started is assigned to the same IP on which the container 1 was working. Right? In that case, if I don't know that container is stopped and I will communicate with the help of the IPs, then I'm supposed to send the call on container 1, but the same call is sending to the container 3. So to resolve this problem, Docker use container names. Right? Docker use container name as a DNS. Right? Let's clear out the console And if you will again start the container one, Docker container, start my nginx one, right? And you will again go and inspect your network. Then you can see a new IP address is being assigned to your container one, right? By this, we can say if Docker used the IP address to communicate, then it may be possible that call may redirect to the wrong container, right? So to resolve this issue, Docker Docker use DNS as a container name instead of the container IP, right? So this is the way how Docker use DNS and how Docker communicate with each others with the help of Docker name, right? So thank you guys, thanks for your time. I hope you like the video.